Let's kind of get started. I'm not going to jump straight into the NeuralColumn development stuff yet, because I just want to, there's some stuff I want to talk about first. So a couple things. Number one is we're eating good. Like, there's a bunch of great open source LLM agent releases that have come out in the past couple of weeks, and I just want to talk about them. So there's Kimi K3. We've got, these are just the three I want to talk about. There's Thinking Machine's Inkling-Small, which has been a really cool model to see because it matches the performance and beats the performance of their larger model. So it's kind of cool to see that a smaller model is able to actually do this. And we'll talk about some of the reasons why. And then the big release this week has been DeepSeek V4 Flash 0731. This is the new Flash variant. It's the exact same architecture. It's the exact same model shape. You can load it up in exactly the same way as your old DeepSeek V4 Flash, but it's had more training, it's had more post-training, and it's a lot stronger. And people are finding it pretty impressive. So I talked a little bit about NeuralColumn, which we started last week. So there's stuff that can be better. I've got a list of complaints from just using the site. I actually think it would be cool to use some of these open source LLMs to try and further do our development on NeuralColumn. We'll just see how they perform. And then there's kind of two projects that I want to call out. First of all, last week we talked a little bit about OpenEnv, but I was having a hard time figuring out what was part of the spec and what was part of the implementations there. So I built my own little project around OpenEnv that just helps to suss that out. I think we can deep dive into it. And then we've got just a bunch of news that's happened this week that I want to just go through. Kimi K3 came out a couple weeks ago on API only, and people were starting to experiment with the API, and also this blog post came out, and people were just blown away because this is the first open source model or open weights model that's made it into this sort of class of the frontier, essentially, where if you're looking at some of these coding benchmarks, like, it's trading blows with 5.6 Sol. It's right up there almost with Fable on some of these. And some of them, Program Bench, for example, it beats Sol and Fable 5. So people were saying, hey, this is incredible. Like, let's try out this model. And if you look at some of the, like, it pushes up not only just the capability frontier, but they're able to do it in a way that it pushes up the efficiency frontier as well, if you look at the cost for some of these things. Now, in the meantime, it's sort of in the intervening time after this model came out, OpenAI has lowered some of their prices and has made some of their models a little bit more competitive. Not necessarily at this capability level, but like at the lower capability levels, making this a little bit less unique. But we'll talk about it later, where some of these open source models are also pushing up that frontier as well. But the cool thing is that, first of all, this is also a very large model. It's a 2.8 trillion parameter model, which is just a lot of weights. That you have to have such a large computer to be able to run this. I mean, we're not talking about a single machine anymore. We're talking about, a rack of, B200s, B300s. You have to have the latest of the NVIDIA technology or the latest of the AMD. You're basically talking at about $500,000 in terms of just buying the server that needs to run this. But if you do have that server, you can run this completely on your own without accessing any third-party service, without paying any money to Anthropic or OpenAI or Google, or XAI. You're not paying anybody. You could just run this yourself for your own purposes. And so that's a massive sort of jump in freedom that you get from just having access to this model. And it's a relatively permissively licensed model. They do have some terms in their license that say if you're going to serve it to others, if you're going to serve this as a service, as an API service, you have to basically go to them for an agreement. And we can talk a little bit about what might be some of the terms of that agreement. One of the things you kind of hear is that GPT-3, that model, got so much stuff right, and the attention mechanism in that model got so much stuff right, that what we're seeing today is just kind of scaled up versions of those. And that is still true, that at its core, these models are kind of just variants and different implementations of that. But as we start to get into this latest versions of these models, they are starting to do things that reinvent in some ways what the attention mechanism looks like. And so it's not so simple anymore as just a multi-layer attention head. Like we've got these more efficient mechanisms. Like in this case, KDA is this Kimi delta attention, where it's a different formulation, and they're kind of strobing in between this Kimi delta attention and the full weight attention. And then we've got these other variants as well. So this is no longer just the standard attention mechanism scaled up. They're doing some interesting things with the architecture here. And we've got all the different model providers that are kind of doing variants on this. They're all co-evolving in similar directions. Like if you look at Qwen, they have something called gated delta net. And this is relatively similar in a lot of ways. DeepSeek sparse attention. These are similar mechanisms where we're trying to take what happens when attention grows normally with normal old school implementations. It grows quadratically. So for every token you add all the computation of all the previous tokens plus the new one, which means that it just keeps getting more and more. At some point, you hit a limit where you can't inference very fast. And so some of these adaptations of the standard attention mechanism make this possible. And if you look at the results on coding, on GPU compiler development, so this is like kernel development, some of these things, it really reaches state of the art. So this is cool. I mean, if you just look at the numbers of their own benchmarks and what people have benchmarked out there, these are really impressive artifacts that it's creating. So now what I was talking about before was it was released under the API. It was released under the SDK. When we first got this blog post and we were reading through it, everyone was excited. People were using the SDK, people were using the API, but there was a big question about, are they going to actually release this as an open source model where anyone can download it? Well, I'm happy to say that as of today, as of a couple days ago, this was released as open source. You can download it. You can look at the files. These safe tensors, these are the actual weights you can download. It's a lot of files. It's a lot of weight. But you could run this on your own cluster if you want. And what's cool is to see the exact specification of it. Is they've changed a lot from Kimi K2.5 and Kimi K2 to Kimi K3. It's a lot bigger. There's a lot more. So there's 2.8 trillion parameters total, and now we're activating 104 billion parameters every forward pass. There's a lot more layers. Let's go to the white paper. This is not an artifact that we get anymore from Frontier Labs. When you look at OpenAI and when you look at Anthropic especially, they are not going to release this type of information. And as we'll see, as we go through this, there is a ton of great information. So let's go through just some of the interesting bits. So this talks a little bit more about their stable latent MOE. So this is like, how are they stabilizing? In the early days of language models, we used to use something called dense models, where every single weight gets read and activated for every single forward pass through the model. And as we have scaled these models up, we've realized that you don't really need every single weight to be activated in every single forward pass. You can sort of, on every single layer, you can select a subset of the weights that you know will be relevant to this query. And they call that a mixture of experts. And one of the problems with mixtures of experts is that they're hard to stabilize. They're hard to train. Why would they be hard to train? You can imagine, just think about like, okay, if you've got 8 different people that you could call on to help, and you know that you've gotten a good answer from person A, and they answered you really well before, they did a great job, and for all these other ones they haven't done as good of a job. You're going to constantly get, if you want the most reward, if you want the best sort of output, you're going to constantly give it back to that first person, and that's not necessarily what you want to do, because if you just do that for your entire training, then that one route is going to get all the traffic, and none of the other routes are going to get the traffic. They will never get better. They'll never improve it at answering your question. And then there's going to be just all the data is going to go towards that one person, And then that one person, yes, they'll be good, but they'll have to be good at everything. They won't be able to specialize in anything. They will get overloaded by all these requests. And then there's 7 people basically just sitting there doing nothing. So with mixtures of experts, there's all these different mechanisms for trying to stabilize the training and say, okay, even though you know that you're going to get a worse answer from these people, you have to spread out the work, and then they learn, they get better, and you can even it out across them. So that's like the mental way of thinking about it. We can dive in a little bit, but they've got some stabilization techniques that they use here. But yeah, so the model architecture, they talk about this is this new Kimi delta attention strobed with gated MLA. So it's not all Kimi delta attention. It's not all gated MLA. It's like it's going back and forth between them. And then there's a really cool thing here called attention residuals, which we'll talk about a little bit later. But it's, I think, one of the more interesting developments of this model in general. I don't think that we've seen attention residuals on any public model as large as this one. There has been a question about whether attention residual scales, and this model answers that question in the affirmative, that yes, attention residuals scale up, and they're useful. You might ask, why are we switching to this KDA in some cases? Why not just do the standard full attention for everything? And this is actually a reasonably good description of why. So you can imagine that if you have to compute all of these boxes in equally, it's going to take more compute than if you only have to compute this diagonal sometimes, and then only every once in a while activate the entire triangle. That's kind of just like a visual representation of the difference between, like, what this is doing is linear attention, and what this is doing is that quadratic attention. And there's different ways, like they've got different ways of making this efficient. This is a great table that just compares Kimi K2 and Kimi K3. Kimi K2 was a 1 trillion parameter model. Kimi K3 is a 3 trillion parameter model. The previous version had 61 layers, and the current Kimi K3 has 93 layers. And in a lot of ways, I think that depth represents intelligence capacity. Like, it's true that width and depth can kind of be interchanged, but we do see in small models that if you expand the depth beyond the width and you push on depth, you can get to certain algorithmic outcomes that you can't get with a smaller one. So while I think width and depth can be interchanged, I think depth is the one that, for a very small class of problems, depth is the only thing that can unlock it. So whenever depth increases, I think that's a pretty good sign. We're also, like I said, the last model was only activating 32 billion parameters. The new model is activating 104 billion parameters every pass. So that's a lot. That's a lot more. Same hidden dimension size, pretty much. More hidden dimensions per expert. This is going to make it better, easier to route between experts, and better, more accurate routing between experts. It's going to more often send it to the right expert. And there's a lot more experts. Before there was 384, now there's 896. And activating 16 per token. We're also increasing the attention heads. If you look at like the standardized attention model, you have a variable number of how many heads you want to activate. And this is a pretty big number. This is a pretty important number to iterate on. Anyway, so they're switching between their attention mechanisms, where it used to just be MLA. Now it's this hybrid between KDA and MLA. They also switched. They found that Swiglu, which is kind of like the standard activation function, they found that there were some outliers. Like, these numbers didn't have bounds on them, and they created this sort of modification of it that bounds the numbers. And yeah, I was talking about how there's like, it used to just be MLA. Now they have it spelled out where some of it's MLA and some of it's KDA. Kimi K3 trained with a whole lot less flops than Kimi K2. So that means that even with all of these increased numbers here, we're still for the same amount of time going to get to a better performance. So that's why Kimi K3 is better. It's a stronger model overall. It came out better in pre-training and it post-trained better as well. And that a lot of that is just due to the fact that it's faster. It's faster to run through all these forward passes. And so they go through their training recipe. I don't think we need to talk about this. This is pretty standard. Oh, one thing that's kind of cool is they don't use positional encoding. When I think about the fact that you can just not positionally embed your tokens, that means your model doesn't know which order all the letters come in or the subwords come in. The tokens that are coming in don't have an order that they're given. So it sees the whole bag of your request as one big long bag, which is crazy that works. But it turns out the model doesn't need them. It just can see all the different tokens you put in. It can figure out the order on its own. And it can reason about it. And it doesn't need all those. It doesn't need a positional encoding. Crazy to me, but true. They trained their own agentic generative reward model. They trained 3 different models. They trained one that was just good at general tasks, general experience, vision, reasoning, faithfulness, search capabilities, and knowledge and work tasks. So their first fine-tune they used reinforcement learning for was just general tasks. And I think this was probably just meant to be like a really task-based thing. Like, I have this thing I want to be done. I don't really care about how you accomplish it, but in the end, this needs to happen, or this observation needs to be had. That you need to have done some search to get some data, and you can only get to this answer if you've done that, for example. Then it looks like general. I don't actually know what the difference is between general tasks and general agents. I guess tasks is probably more one shot, and general agents is probably more, I guess, long horizon. Okay, deep research, paragraph level writing. And then the third one is coding agents, which you can imagine is like, it has to learn about all the coding languages that people would want to use. It has to have specialized knowledge in something like kernel development, web development, things like that. So they trained these 3 different models: general tasks, general agents, and coding agents. And they say that, and you can see that, like, as they scale RL, they just get better and better at all these things, right? In their generative reward model, they first have like the model assess the rollout, generate a rubric for it, and then score against the rubric, which is kind of cool. But okay, so once we've got these 3 models, the general tasks, general agents, and coding agents, they do something called multi-teacher on-policy distillation. And actually, the first time I really saw this formulation, this multi-teacher on-policy distillation, was in the DeepSeek V4 paper end of last year, where they do a very similar thing. And I think what's happened is that everybody's converged onto this. On-policy distillation says, so okay, each 3 of these models started from a base. You've done pre-training, you've done some amount of post-training, and then you have this like generic base model that you start with, mid-training, post-training. You have a generic base model. And so from that base model, they created this tasks, agents, and coding, right? You go back to the same model that you started with. And with RL, when we're talking about these RL stuff, it has to generate an entire sequence of tool calls and do a lot of inference until it gets to what it thinks is the answer. And then it says, here's my answer. Yes or no. Is this good or bad? Or maybe give me a number about how good or how bad this is. But in the end, you do all of this work, and then at the very end, you get one number back. And so it's very inefficient. You can think about this as like being limited by our inference speed. How fast can we run these forward passes? How fast can we like run these agent rollouts? But once you get to these 3 specialist models, you have experts. You have 3 experts that are really, really good at these things, right? And so you go back and you start from the same base model that you started all these experts before you trained them. You give prompts to this. So you generic prompts that span everything that you want to do. And you give it the prompt. It doesn't just output the next token. It outputs a probability over all the possible next tokens. And so you take the probability across all next tokens and you present it to each expert. And you can basically use a mathematical formula to say, okay, how much does each expert and how confidently does each expert agree with the distribution that you've put out? And you can basically take all those experts and distill it and say, okay, between all these three, this expert and that expert are very confident, and they say that, you know, it doesn't, you should nudge your distribution slightly this way, slightly this way. And so as for RL training, you have to do all these tokens for a rollout. When you're doing this expert distillation back using on-policy distillation, every single token that it outputs gets scored by all three experts. And so it's a very quick way of taking these like super specialized experts and sort of merging it into the base model in a way where they're all working together. You don't have three experts anymore. You have one model that's really good at everything. And by doing it on policy like this, by taking a model's own outputs and scoring it, you're always improving the policy as it exists in that base model. A lot of older formulations did off-policy distillation, where they would sort of like, this is a good example, this is a bad example, like take that and nudge your policy in that direction. But oftentimes, the good and the bad example were both not something that the base model would have put out. So it's kind of just like shifting it around in a space that doesn't make sense. But with on-policy distillation, every token that the model outputs gets scored across 3 experts or 5 experts, however many experts, but in this case, it looks like 3. And then, so it's a very, very, very dense training signal. And the GLM 5.2 paper said that they can do the on-policy distillation in 2 days on their cluster. So it's a very dense signal. It's a very quick step in this process, but it's very powerful because you're taking these experts and you're sort of merging them. And so you're getting a powerful model at the end. So that's kind of cool. Seems like they did quantization aware fine-tuning, where they're using basically efficient fine-tuning, where they're using lower bits for certain parts of the model. That's pretty cool. Then they go into a lot of detail about their various different RL environments that they have set up. So like they categorize it into these various different types of tasks, where you might do coding, you might do chemistry, you might have a math thing. And they synthesize all these different tasks. Research and knowledge graph construction are good tasks. They also specifically implement kernel optimization, which means that the model is getting better at writing code that the model itself will use, because a lot of times the limiting factor on how fast your inference can go is how good your kernels are. How well are you taking advantage of the GPUs that you have? If you've got bad kernels, you're going to be using those GPUs inefficiently. If you've got really good kernels, you're going to be using them more efficiently. And as we've seen in the earlier parts of this paper, as fast as you can inference is as fast as you can train. And so it just makes that a lot better. It looks like they've also created mock implementations of Gmail, Notion, Slack, and Canvas. Like this starts to get into this, like, if all of a sudden you notice your model gets way better at doing Gmail, well, it could be because they simulated it. They created an entire simulated version of Gmail and then taught the model to interact with it. And so you'll see this on like things like Slack, or if all of a sudden one of your use cases gets a lot better, it's highly likely that the model company built some environment like this. And in fact, web development, we'll talk about it soon, but Kimi K3 has some of the best scores of any model anywhere on web development stuff. So that's pretty cool. And you can tell that a lot of this is based on their curated web development tasks that they've built and the rubrics that they've got for training against it. They talk about they talk about their context parallelism and how they're able to split things off into different compute loads that can happen at the same time and then combine, and how they can figure that out using the like attention patterns. This is like where it starts to get just super cool and insane, is that sort of because these things are disaggregated, they're distributed across different nodes, you have to be really clever about sort of, okay, I've started some work on here from this part, and it has to transfer over the network or transfer to another device, and that other device is going to run another pass on it or do another thing on it. And we can't do anything until with that piece of data until it's been transformed or done something in the other part of the architecture. And so you can kind of trace like the number one through here. And this is like one piece of data where you're gonna be very careful about what you're doing when, and you're not going to just only compute basically the number one data, because if you just do compute the number one thing and then just wait for it to be done, you're going to be waiting until like basically over here. The idea is that by carefully selecting which order you're working on, what operations, you can basically multiplex and create a situation where you're never waiting. The only time when any of these GPUs are waiting is in these blank spots. And that's what we're trying to minimize, is these number of blank spots where you're doing nothing. And using this particular setup that they've figured out, that's a very, very efficient workload where it's really not pausing very much at all. There's very few bubbles in the pipeline. We talked about balancing MOEs and how it can be difficult, but they found some stuff. They created this MoonEP, and MoonEP actually has open source component where if you look at this, you can see this is a massively improved algorithm compared to DeepSeek's version. And I think a lot of people are going to switch over to this right away. Before LLMs, maybe you had like, we had convolutional neural nets, and we were doing things like image detection, image segmentation. So is this a bird or is this a cat? Something like that. And you would run your forward pass through all of these different like convolutions, and you'd say, I'll do a convolution here, I'll do a convolution there, and every single layer was like a convolutional layer. So the difference between that model and the current model is that you see all of these like these lines along the outside. Why do those exist? Well, those are called residuals. If you look down here, we talk about this later, where how many layers do they have? The old Kimi K2 had 61 and Kimi K3 has 93. There's no way that we could get 93 layers by just passing it from layer to layer. You pass the output of one layer to the input of the next layer, you pass the output of that layer to the input of the next layer. If you just did that the whole way through, what happens is you get something called the vanishing or the exploding gradient problem, where at some point the signal gets lost. Some layer is either mistrained or activates in some certain way that just like either sends a number to zero, and then multiplying by zero by like you keep multiplying zero by anything and you get zero. And so you can imagine like whenever anything goes to zero, everything else in the chain is going to go to zero. You can do a lot of tricks where you sort of try and prevent it from ever hitting zero or ever hitting infinity, or you prevent it from the edges, but the problem remains the same, which is that this original sort of input that came in at the beginning, it has to pass through so many layers that it's hard to keep it intact. And so what happened was Microsoft came up with this idea called ResNet. And it was really popular as soon as it came out because it just helped so much. And what is ResNet? ResNet is the concept of like taking the original weights, like the original signal, and just passing it through. So that there's like a super highway of information that goes through all of these. And there's always a signal coming from that very first model, or from that very first thing, and is added at every layer. And so this has been basically the way that everything has worked since then. Everything has done this. They added it in ResNet, and then when Transformers came out, it was just a pretty much a constant part of the Transformer network, where you've got this signal that's going from the very beginning, and then each time it just gets added a little, added in. So the problem with that is that it's still got a bottleneck where the previous output of the previous latent kind of needs to be routed through to the next one. and the previous output needs to be routed to the next one. And so while it is like a superhighway, it still does kind of like lose some of its predictive power, and it loses some of its signal. As well as every single layer might kind of like do a slightly different thing with that original. It might want to do a slightly different thing. So maybe it's looking for a specific feature. Maybe it's looking for a specific, I don't know, piece of information that, you know, we don't exactly know what these layers do yet, but what people started to realize is that those layers, like each one of these is kind of its own interesting view of that original residual, that original thing that came through. At each layer that some feature gets trained to look for it, it would be nice if, for example, we could look at all of the previous residuals, like every single activation. And so what attention residuals does is say, okay, let's bring that all of the previous residuals. So for a layer like, for a 96 layer thing, each one would be looking at like a mix of all 96 layers and learning which one is most interesting for this one. So instead of looking at one superhighway, you're looking at a superhighway that just expands out, where each further layer gets to see all the previous layers. Problem with that, like standard attention residuals, is that you can imagine it starts to get really prohibitively expensive, especially in a distributed system like this. If something in one of these later layers needs access to like a bunch of information from the earlier layers and it can't be sort of passed along, then we've got a big problem. The idea is that instead of having it look at all the previous outputs, we're grouping them up in these blocks. And then you're computing for an entire block, how interesting is that? And that's how it can all be combined before it's used in the actual residual. This is just a way of making it so that it's possible to be computed in the budgets that we have on these forward passes and things like that. I think it would probably be better if we had full attention residuals, but the block attention residual is like a really good way of making it computable in our time, like in tight timelines. Anyway, they go into a bunch more about how they create their evaluations, cybersecurity, all these other things. I think at this point I'm going to stop reading the paper, but I just want to call attention to the idea that like it's so nice to get this paper and see all the different things they tried and see the details, looking at specifics about all these little choices that a model provider has to make when they're training their model and when they're inferencing. One of the things that I said earlier was that if the model license is not exactly, it's a permissive model license, but it's not a standard model license. One of the things that they said in this model license is that if you want to serve it over an API and charge for that API, you need to come to us and we will provide, we'll come to a deal, and you have to come to an agreement with them before they license it to you. And one of the things that's been pretty clear about this deal is that you're not allowed to undercut them. It used to be that just everything was 315, 315, 315. It seems like some people are going up, people are raising their prices. So the fast version of Fireworks is charging more. You can't make the price less. So that's interesting. That changes the dynamics a little bit. If they're saying that basically there's an MSRP on this and you can't go below that, it means it sets a price floor on it for everybody. And I think there's some really good aspects to this. It means that the developer of the model can sort of recoup some of their money. Even in some of their deals with these companies, I don't know what those deals look like, but I'm assuming there could be a financial component to that. But in another part of it is that they're able to set this price floor and say that we're not going to like do a race to the bottom here on our prices. It remains to be seen whether the market bears that. But I think it's just an interesting aspect to talk about. I think I'm a little conflicted on the whole concept, because I do think that these model providers should have a way of recouping their investment. Clearly, there needs to be something for that. Well, in this case, these providers do not train on prompts. In general, I've turned off routability on the ones that I don't trust. And a lot of the reason why I wouldn't trust it is that oftentimes these providers will not provide an option that doesn't train on prompts and doesn't retain prompt data. In this case of this model, it looks like there are a lot of these providers that I generally don't trust that are providing zero data rate. There is immense value for being able to capture these traces. And I think we should know the terms of these deals. Like, that helps us reason about whether or not to use this model. So what's cool is that Moonshot is actually collating this list of, if you look here, this Kimi vendor verifier. They're providing a list of different providers and how they score on various different benchmarks. The idea is that, like, sometimes, like, for example, if you have a model provider that is that has misconfiguration of their inference stack, or let's say they're trying to save money and provide you with something that seems similar or it has the same name on the tin, but underneath it's actually, quantized, or they've done something to it. This is a way for you to sort of track that and say, okay, it looks like in these studies, they're all kind of configured properly, at least according to them. But I think this is a cool way that things are going, where you've got this model provider that's sort of running evaluations and checking the performance of all the different inference providers. The model provider and the inference provider, when they're the same, they can kind of optimize their own stack together. But when they're different, you need some sort of coordination mechanism for figuring out, like, hey, ours is like, don't use the DigitalOcean one because it's misconfigured or something. Wait until they figure out their configuration issues, or wait until they stop quantizing their model, or whatever it ends up being. In this case, everybody seems to be acting admirably, but in the past, we've seen a lot of problems with this. So I welcome this. But the main thing, one of the big things that has been exciting about this model K3 is that it's really good at front end stuff. When it comes to code, when it came out, it was the top. It was by far the top of the model. Now, I actually checked, and it's no longer the top of the model. It's second highest. 1676 was it before, 1679. So it's dropped by just a few points. But Claude Opus 5 at max has now surpassed it. It's at 1705. So that's not Fable, by the way. That's Opus, which is kind of interesting. But Opus has had further training. The more efficient your inference stack is, and the more you can sort of run through, the better your performance is going to be. And this, like in this case, lower is better. And if we look at this, I think that's probably similar to why Opus 5 is getting a little bit further along, because it's faster to train it, and so they can run their RL on it just a little bit faster than they can. Also, Fable has been around for a while. There's no 5.1 yet. So that makes sense as to why Opus could have outperformed Fable on this. Opus is newer. It's gone through more post-training, and it's faster for it to post-train than Fable, probably. We don't exactly know all these things, but that is why it could make sense. But Kimi K3, with an incredibly impressive showing that open source can absolutely compete. And even at the price levels, it can absolutely compete. And that's it. So K3 has been an impressive model. I've actually been using it quite a bit, and we can use it more today when we do some of our NeuralColumn work. But I feel that K3 was a big moment in open source because it meant that open source finally approached the frontier. And once open source approaches the frontier, it makes all kinds of considerations change. It means that potentially you could liberate yourself from ever paying one of these companies again, theoretically. You have to spend $500,000 to get the resources to do it, and you still won't be inferencing as fast as you could on some of the shared infrastructure of a scaled provider. But this is an absolute game changer in a lot of ways. So K3 pushes up the capability sort of front. And the next model that I want to talk about is Thinking Machine's Inkling-Small. So what is Inkling-Small? Inkling came out a month or two ago, And Inkling, I think we've got a blog post here, July 15th, just 1 month ago, or a month and a half ago. Actually, half a month ago. This world moves so fast. But this was their first open source model from Thinking Machines. And when it came out, it was reasonably impressive. Like, it actually performed quite well on a lot of the different evaluations. And it's not a insanely large model. It is a 1 trillion parameter model with 41 billion active. And so we were talking about Kimi K3 before, which had 3 trillion parameters with 100 or so billion active. This is 1/3 of the size, basically in all fronts. So it doesn't beat K3, but it does sort of hang up there with GLM-5.2. It hangs up there with these other models. It doesn't hang up there with Sol. It doesn't hang up there with Fable. But like, compared to the previous open source models, it absolutely hangs up in that weight class. So they had promised in this blog post to release Inkling-Small soon. And small one was even smaller. This is a trillion parameter model, which is not, again, K3 is larger. It's 3 times larger, but this is also not a small model. A trillion parameter model is quite large. You still need a very, very powerful set of GPUs to run that. So what about Inkling-Small? Look at the difference. Inkling-Small comes out and they say, hey, look, if you consider 975 billion parameters, this new model is a lot smaller. Not only are there fewer parameters total, but the number of active parameters are way smaller still. So whereas with the K3 we were at over 100 billion parameters active, this is only 12. So we're activating, and this is these dark numbers are the ones that really are your limiting, are the ones that limit your performance. If you have like all of them are dark, where all of them are active, it's not a mixture of expert, it's dense, it's going to be very, very, very slow. So the sparseness of this is one of the things that really contributes to its speed. And so they talk about, okay, it's been trained on NVIDIA chips. It's 276 billion parameters with 12 billion active. And look at this. It beats the performance of Inkling. It's literally better. This is the small one. It's getting better performance. And it's using a lot less flops to do so. So the bottom row is the compute that's used, and the top row is the performance, like the output quality. So at its lowest performance level, so if you look at like if you look at the matched configuration wise, the lowest performance setting of Inkling-Small does worse than the lowest performing setting of Inkling. But as you scale the different thinking levels, once you get to this X high level, which would be the second one down, we're beating it. The smaller model is beating the larger model. So that's been incredible to see. If you look at the capabilities between Inkling and Inkling-Small, this makes sense to me, where Inkling is doing better at factuality. It knows more things. It knows more facts. It has a bigger set of weights to hold more of basically the world knowledge inside of it. But when it comes to things like interpreting vision, doing chat tasks, reasoning, writing code, look at Inkling. The Inkling-Small, you can see it's actually doing a little better in the code writing ability. And I think this goes back to what I said before about the how inference performance affects your training capability. And if you can run more tokens through it, you can run more training runs, you can run more trajectories, you can hill climb faster. And so with the same amount of budget, you can get higher on the charts than you can with a smaller model, at the cost of factuality, at the cost of world knowledge. And so I think what I'm really interested in seeing is how small can we make these models? How far can we push this concept of, like, what if your factuality goes down to like 0? What if you push it all the way down? But maybe you can get like a very tiny model that still retains a lot of these reasoning and a lot of these coding and agentic abilities. That would be really cool. Yeah, we could talk more about, more evals. Multimodality. Remember, Inkling-Small not only has image capabilities, but it also has audio. They've been training it with audio. It hangs up there with like Gemini 3.5 Flash Lite. It's right up there. It's way better at audio because it's actually been trained on audio samples. And yeah, on Voice Bench, MMAU, these are all audio tests. It seems to hang up there with the best. In fact, Audio MC, it's better than all the rest. It's an incredibly impressive model for its size, I have to say. They've even pushed on safety as well. So this is actually another open source model. We have it's launched, it's available on Hugging Face, so you can download the weights today. And this is Apache 2, which is one of the most permissive licenses that's available. So the idea is that you don't need to pay them a specific amount of money if you want to host it on their API. You don't need to do anything. You can just do whatever you want with this, basically. Just don't try and present yourself as them. I think is Apache 2 basically prevents you from stealing their copyright, but it doesn't. It's MIT with a little bit more legal weight, is my understanding. And so there's the full model, but they also provided from themselves the Env FP4 version. So this is the pre-quantized version that's specifically set up to work very well with NVIDIA chips and the NVIDIA quantization setup. So that's cool. It's cool that they've provided this. It's wonderful that we get that K3 white paper because we just don't necessarily know that we'll get that from other actors. This is one of the announcement posts, and basically what they're saying here is that it outperforms strong peers in its class, including DeepSeek V4 Flash. I included this because this did not last. They posted this, and the next day, DeepSeek V4 Flash was updated to improve on them. So that's a little bit of a spoiler for what's coming later. But yeah, this is kind of cool because he says that Inkling-Small began with an on-policy distillation from Inkling, which we talked about that on-policy distillation idea before. And that allowed it to catch up to Inkling very quickly. And then they ran 2 weeks of continuous RL. That's it. And produced a much stronger final model. It sounds like they didn't do the multi MOPD thing where they trained specialized experts and then distilled them back. It looks like this was just RL. But you can imagine where things are going to go in the future. Do RL experts and then OPD it back on. And then what's kind of interesting about this is that they describe this as feeling like just routine. Whereas with the previous Inkling model, it took a lot of effort. They had to set a lot of things up from scratch. They had to build their data pipelines. They had to do all that. What they feel is that this was kind of just like turning their model factory on and setting it to a smaller setting, which is pretty cool. It's kind of cool to see that they're getting into a cadence now where maybe we're just going to see more and better and faster releases from them. This was certainly a fast follow-up to their initial release. And this was kind of funny. Like, why not name it Shrinkling? I thought that was funny. And then what's cool is that not only has it launched, but people have already created optimized versions of this. So people took this and did a DSpark fine-tune. DSpark is this new way of doing speculative decoding using diffusion. You start with the original model, do some fine-tuning on it, and voila, you get this incredible fast speculative decoding thing where you're getting the exact same tokens out, but it's proposing like chunks of them at a time. It's proposing 4 at a time or whatever. And then as long as those 4 match up with the 4 that it would have produced, you can just output those 4 right away. And so using this type of a setup, which is great, the open source community can provide, they're getting 648 tokens a second, which is just insane. So this is a small model that's got relatively fast performance that the community has built fast speculative decoding on, and you're getting reasonably fast speed. Like, that's a fast speed. If you felt that on your agentic outputs, it's going to feel way faster than like the typical OpenAI or Anthropic models. You're getting like 50 tokens a second with that. So 650 tokens a second is going to feel just insanely fast, which is insane. It's great. It's incredible. This is the benefit of the open source community providing these types of things. This is an incredibly exciting model because it's just so much smaller. It's hitting the same sort of heights on some of the benchmarks, and that means that you can do it cheaper, you can inference faster, you can fine tune faster. That's one of the things they really. This is ultimately what thinking machines is about, is fine tuning. So they provided a model that's going to be very good and fast for that. So we talked about K3, which pushed up the capability frontier. We talked about Inkling-Small, which seems to match their previous capabilities, but at a much smaller model size. And then comes out DeepSeek V4 Flash at the end of the month. They said they were going to have some updates in July, and they waited until the last day of July, but they got it out there. But what is this? What is this? It's a massively upgraded version. If you look at these numbers, the old numbers and the new numbers, this was the previously open source version of DeepSeek V4 Flash. This is the new version of DeepSeek V4 Flash. This is the same model. It's actually the same weights. It's the same architecture. You could load up anything that you used in your previous DeepSeek V4 Flash, swap out the model weights, and you get this. And we're talking a huge jump from 61 to 82 on Terminal Bench, from 39 to 54 on NL2, from 38 to 76 on CyberGym, from 7 to 54 on DeepSeek, which is like software engineering tasks. This is like what people really use this stuff for. Every single number we're looking at here, they've just done so much improvement on it. And I think it ties into a lot of what we were talking about in the previous two open source models. The faster you can inference, the more you can hill climb. And they have been hill climbing. So that's pretty exciting. Not only was it announced, but that same day, hours later, they released the model. This one is MIT licensed. It's the most open and permissive license you can basically ask for. And you can slot it in with all the other things. They also released themselves the DSpark. This is the efficient speculative decoding stuff that I was talking about that an open source lab did for the Inkling-Small. In this case, DeepSeek released it themselves. They've trained it themselves. So you're getting, this is the way of making it go very, very fast, and they're going to make sure that everybody has access to that. That is incredible. And if you look at it, it is 304 billion parameters, and we'll talk more about it. But also, right on day one, we had Unsloth create GGUFs. This means that if you have a computer that has a lot of RAM, a lot of VRAM, maybe you've got one of the new Macs that maybe you've got an M3 Ultra that has more than 128 gigs of RAM, VRAM, you could potentially run this. So as long as you have essentially 102, well, I wouldn't use the 1 or 2 bits. I probably wouldn't use the 3 bits. But as long as you've got more than 162 gigabytes of VRAM, whether it's unified or not, you can run this, which is crazy. So it's cool that Unsloth was able to create their GGUFs right away. And people have really been trying to optimize the performance on this, trying in a bunch of different configurations. So we've got the TinyGrad, which they have a setup with 2 RTX 6000 Blackwells. Those are 96 gigabytes of VRAM. So combined, you've got enough to run these things. And they're saying that they're hitting 245 tokens a second, which is incredible. Like 265 tokens a second, or 245 tokens a second, is probably like 5 times faster than you're going to feel like GPT 5.6 Soul. This is super fast. This is great. It's unfortunate that it requires 2 GPUs. It's just a little too big for one, but this is an incredible result. By the way, these TinyGrad things, I think one RTX 6000 Blackwell GPU costs about $10,000 by itself. So if you wanted to put together a system for yourself, not using TinyGrad, not using TinyCorp, you could basically buy this. That would be like $20,000 for the GPUs, you're going to spend probably, let's say, $5,000 for the rest of the system. So for $25,000, that's a pretty reasonable setup for a reasonably good frontier quality model. We're not talking like GPT 5.6 Sol Frontier. We're talking like GPT 5.6 Luna Frontier, and that's pretty impressive that you could get that for $25,000. You're going at 240 tokens a second. I just can't think of any business that wouldn't be improved by having that type of a setup and not having to pay for any incremental costs. You're just paying for your energy at that point. Pretty impressive. But then also we have these DGX Sparks now. These are kind of like desktop computers. I think I don't know what they cost anymore, but it's like a very small GPU core combined with a decent amount of memory. I think they're 128 gigs of unified memory each. So 128 gigs of unified memory isn't necessarily enough to keep the whole model on one. So this is somebody who's tried, they put together two. They've got two DGX Sparks connected, and they're finding ways to split the model up and run it across both. And they're seeing about 100 tokens a second, 95.9 tokens per second. And if I understand correctly, they're not compromising by doing crazy quants or something like that. I think this is reasonably standardized inference. And it's all open source. You can download it. You can do it today. You can use it. However, a lot of people don't have two Sparks. They've got one. And what this person has been working on is a way of smartly allocating what ones are on disk, what ones are in RAM, and then figuring out how to page those out properly, is my understanding. And so they're not overly quantizing it. They're not like removing a bunch of layers. They're not destroying the model. And what they're seeing is that they can get to 59 tokens a second. Now, this is not 59 tokens a second for one user. They're sending like a bunch of things through this at once and using bigger batch sizes. This is like pushing it a little bit in terms of, I don't know what you'd actually get for a single agent serving. I'm not exactly sure, but this is pretty cool. And then somebody got it working on their M3 Ultra. So using Dwarf Star, and they've got it running at about 27 tokens a second. This is, for me, my personal feeling is this is about like the limit of what you could use before it starts to get too slow for your own agentic coding use cases. If you're sitting there and like looking at the output, obviously if you've got like some background process using background agents, then you can push the tokens per second even lower. But for 27 tokens a second, that feels real time. That feels reasonable for an agentic coding workload. And so we looked at the official benchmarks, but let's look at the benchmarks from the different companies. This is an incredible leap from like a score of 40 to a score of 50. He is hanging up there with like GPT 5.6 Luna at max. GLM 5.2, which is a much, much larger and slower model at max. Muse Spark, which is the best thing that Meta has released yet so far, at their highest setting. Like, it's pretty much right there with those impressive models at this point. And we're starting to get to the point in this class where you can do a lot of tasks. It's not limited to feeling like it's a small model. We're starting to feel like when you get to this level, you start to feel like this is a capable model that can really accomplish the tasks that I needed to do. And I think this is maybe one of the most striking graphs of the whole thing, where this is what you could kind of consider the Pareto frontier. This idea of like, for the cost, what am I getting out of this? And I think this chart was created before the Luna price changes, so that might shift it over this way in terms of like the cost. But look at how much more intelligence you're getting for so little cost here. And this is the same model. So this just shows you the power of post-training. This shows you the power of RL, really. Look at this as an outlier on this graph. If you can kind of like chart a line, like if you did a linear fit between Mimo v2.5 through to Claude Opus 5 Max, you'd get this reasonably good line that would kind of go through everything. Now, DeepSeek V4 Flash would kind of like push it up, but this new thing, these new Luna and DeepSeek V4 Flash 0731, this is going to not fit on that line. This is creating a new line. You should just look at this leap from 1189, same model, more post-training. Now we're at 1559. Again, right trading blows with Luna, trading blows with Terra. Not too far away from Opus 4.8, frankly. GDP-val is a very strong benchmark. I think GDP-val was created by OpenAI themselves. Obviously, you're still not, this is 1559, you're not getting up to GPT-5.6 Sol at max setting. We're not there exactly with this Flash model, but this is a Flash model. This is a fast model that you can run on one DSpark, or one DGX Spark. So it's really not just the capabilities that are impressive here. It's the capabilities at this cost. It's at this speed, at this accessibility level. It's pretty much impossible to think about an end user buying the hardware that it takes to run Kimi K3. But I could run out tomorrow and buy the hardware. It would be expensive. You buy a car and you drive it for years. And I think that we're getting to the model class where you could buy a car level of computers and run it for years on this stack. And you just know that this is going to get better and faster at the same capability, at the same inference class. Yes, it could be a lot better, but this is no slouch of a model. And that was then. This is the live actual data as you look at it today. So has anything changed? I don't think so. This is still by far the best cost per task. Interesting also to look at the tokens used for the task. It uses more tokens, but they're so much cheaper. But it is important to note that it does use a lot more tokens for its reasoning. 37,000 tokens in reasoning versus Kimi K3 using less than 2,000. So that's a big difference. So this is something they can still push on. Imagine if we could get this down to there, to this area. That would be incredible. But what we do see in general is that with smaller models, they need to make up for their lack of size with more reasoning tokens. That is just something we generally see. It also could be something to do with the training process, and it could be that like with better post-training, you could push that down. For example, like GPT OSS 120B, we know that OpenAI knows how to post-train their models to be efficient reasoners. And even with theirs, they're hitting these high numbers on the amount of reasoning tokens. I've done a bunch of experiments with like a 4B model, the Qwen 3.5 4B model, and I've found that in general, it requires tons of reasoning tokens to just get to the right answer. And if you cut it off early, it gets wrong very quickly. So anyway, something to know about. But even still, even with the higher number of tokens, it still costs so much less than all the competitors. So we are spending more tokens, but we're getting, even though we're still hitting low costs. So that's good to know. Now, the code arena. We talked about before how K3 had the top score when it came out, and then Opus 5 just recently surpassed it. Where does DeepSeek V4 Flash sit? It sits right there. It sits up there with GLM 5.2. So while it's not hitting these highs that K3 has and Opus 5 has, it's hanging in there with the other open source models and the bigger ones. This 5.2 is a much bigger model. You can just see the Pareto frontier, like this pushes out. It's such an outlier in terms of the capability you get for the cost. Like if you look at Laguna XS, this is an open source model. These are all the open source ones, right? I guess this is the one non-open source, but with Kimi K3, it's hitting these highs, but it's also relatively expensive. And as you go down the price curve, like we're talking like 20 cents here. This is the next closest open source model. Like this is a very good open source model. But DeepSeek V4 Flash is just so much better. And then here is the Simon Willison Pelican test. And as you can see, he got on default reasoning mode, he got a pretty bad one. Not so great. This isn't great. But he bumped up to the high reasoning mode and got a lot better. This is night and day. So this really goes to show you the power of the reasoning modes and how many more thinking tokens it uses and how much that can affect the quality of the results. Also, this looks like it's been post-trained. Like, honestly, I would be surprised if there wasn't something in the training data that created, like, this is a really good Pelican, in my opinion. It's not perfect. It's like, there's some weird stuff, but this is a pretty good Pelican. So the other thing is, there's a bunch of free providers of this. OpenCode Go has a free version of this. So if you download OpenCode, you sign up for an account, you have free access to, for a decent amount of tokens, to this DeepSeek V4 Flash model. Also, Hugging Face themselves opened up a endpoint. It's a free model. You can use it. You can connect to it. You can. I think they might still have it up, but this is the one that I'm not sure about. This one might be down by now. Klein, they're another coding provider. They have provided a free version of this for you to try out. So everybody's trying to get you. Also, I don't know what this ZenMux is, but they also provide it for free. And they can afford to do this because it's just as few GPUs they have to spend on it. It's not some big hardware layout. They can just repurpose a couple GPUs and say, hey, try our service for free. That's cool. So this is a really exciting release. A very impressive. So between all three of these, we've got K3 pushing up the capability frontier. We've got Inkling-Small proving that like a Western lab can do all these same things and release it open source, and it matches their larger model. And this is just an indication for where things are going. And they've got their model factory going. Like that felt routine to them. And then now we've got DeepSeek V4 Flash, which pushes up the capability, cost, accessibility frontier. So that's a really cool set of open source releases just in the last 2 weeks, really. And really, in the last week, we've got these latest few. So this really, I think, even just in absolute terms, these are great models to be using. Each one of these you can use today for tasks that you've got today. But I think what's more interesting is to look at the trajectory of these models. These smaller models that are able to post-train faster, these model factories, they're becoming more routine. They're able to distill from their larger models using OPD, MOPD on their existing models and match them and improve upon them and go beyond. So this is just, I think, an indication of where things are going. You're going to get faster, better, more powerful models over the course of the next year. I don't see this slowing down. What will be interesting is this graph, where as we push on these other capabilities, as we're trying to extract more and more of the coding capabilities, the terminal bench, we're trying to basically keep these fixed or push them further. How can we keep, like, where does this go? Does this go down further? Do we sort of steal capacity from the factuality and from the world knowledge in order to sort of reallocate it towards reasoning and coding? Or are we going to find capabilities and ways of sort of like making it better at all of them? And will we be able to push the accessibility factor even lower? Like, what if there's a 32 billion parameter model, or a 16 billion parameter model, or a 4 billion parameter model? How far can we push that like lower barrier, and maybe sacrifice some of the world knowledge and some of the general knowledge? But like, how much can we retain these performance and maybe even push further on some of these useful tasks? So that's, I think, like what's really interesting to think about for the future. Let's use some of these models. So NeuralColumn was a vibe coding project that I started last year. And I had the idea that it was going to be this like think out loud, like sort of ramble, and then turn those rambles into blog posts. And how could I turn like a rant in the car that goes on for 45 minutes into like a condensed blog post that succinctly shares my views and captures what I was trying to say in that long rant. It turns out that that's not a great product. It turns out that it's too easy to just like turn into slop. And in general, things have kind of pushed in the other direction against an AI intermediating all of your words. So last stream, I gave a vibe coding task to say, hey, delete this entire site and let's replace it with something that's a little bit more like just an editor from Markdown, because I wanted to create the show notes, for example, for this. And so last week, these are the show notes from last week where I was like, I used this site itself afterwards to compile and take this Markdown. And you can see that as you sort of like edit things, it updates here. And I basically typed in a big long prompt and then tabbed away. And 4 hours later, this site is basically what we got out of it. But, now I've been using it. I used it also to compile all the things that I wanted to link to this today. And I have a list of gripes that I want to improve upon. So here's one thing is that I don't like the way that styles work. I have this sort of design thing where I can say, let's make the background light. And theoretically, it should work and do this. And actually it did. Oh, that worked. So, okay, this is actually working. I like the concept here where I can kind of like edit this and I can see how it's changing the post. And then what's kind of cool is that if you go to the published site, that's not what I wanted. I just changed this in development mode and I went to my published site and I refreshed it and it's showing the new update, which is not what I want. I can't see the CSS. I can't really see what's going. I like the concept of being able to like talk about the design of it, but I've also had problems where it kind of decouples, where when I switch between the text and the design, like it had different styles in the preview mode in text mode than it did in design mode. Like that's not right. So the whole style thing is not the way I want it to be. The other thing is just this agent in general is very janky. It's very weird. Like actually in the two examples that I showed over here before, the diffs did apply cleanly. Copy, edit my neural column section. Let's just say that. So this is like one suggestion. So let's see how this works. But I've noticed that when I try this in the past, oftentimes it doesn't apply cleanly, or like it like replaces the entire site or something like that. In this case, it looks like it actually did a good job. But I don't like the edits. But anyway, that's kind of cool because this is actually an example of it working. But for example, like if the edit is wrong, let's say that so actually I didn't like this. Let's say I actually want to keep it very technical. Let's just say that. I don't have the ability to like edit this or give a ton of advice. Actually, this is working a little better now. I think maybe it's luck of the draw in terms of what you're getting from the model output. But like that's actually a pretty good edit. And I'm liking the fact that I can sort of undo them. That works pretty well. But I think, okay, so that goes into this idea of like, we could probably use a stronger model for this. Like this is GPT OSS 120B. And while I'm getting good rolls on this dice right now today, it's not been consistent. And I had a lot of problems when I was using this earlier. So unfortunately, like, I wish I could show it failing in some sort of strong way. But in this case, I just happen to get good results. But I think let's switch to a stronger model so that it's less of a crapshoot. We're going to just get better results out of the box. In fact, we can use some of these new Kimi K3 or DeepSeek V4 Flash. Actually, let's try DeepSeek V4 Flash maybe and connect that up to this. Or maybe let's give it a model picker where we can choose. And then also I've noticed that since I had problems in the past of like applying the edits or undoing the edits or figuring out how to do that, I think we need to investigate and strengthen the protocol between the notebook and the agent. And yeah, this overly modal, we've got text and then we've got design, and those are these two separate tabs. I kind of want it all to just be one. And I want to, if I'm talking about design, the agent should do design. And if I'm talking about text, the agent should do, it should just have access to both at the same time. Also, I was trying to figure out, okay, how do I bold something? And I found that, yeah, if I select it and do Control B, I get bold, and I can do Control Z and undo it. And if I just manually type that stuff, that works too, right? But if I don't know the markdown format, or if I forget some syntax, and if I don't know the built-in keyboard shortcuts, then I just want more help and guidance, so I can, like, maybe I can pop open and get a quick help guide, or maybe there's like a little hover button over here that shows me the different keyboard shortcuts, or maybe there's even some like buttons on, I don't know if I want this, but maybe some buttons that have like bold, italic, whatever, things like that. I did notice in the past that sometimes when I'm looking at this split and I switch between text and design, they have different styles. I'm not seeing that today. I think maybe that was a cached thing on my other computer. But in any case, we noticed that when I made those design changes, it was editing the production CSS. So we want to figure out what's going on with all that design stuff. Also, this visual design, like, it's okay, but it could use some work. And then also, if you look at this, like, when I shrink it to a mobile viewport size, when I have the agent open, the agent takes up the whole thing. Like, that's probably not right. And if I close it, it sits here. If I have split selected already, and then I get to this side, it keeps me in split mode, but then it shows me only the edited version. And I have to, like, switch between text and preview. It'd be nice if, as I get smaller, this split mode, it automatically transitions me into the text mode, and maybe things change around and are more suitable for a mobile agent. Right now, like, you get this weird experience where the agent kind of takes over. You can't see the design very easily. The split mode, if you're on it, it doesn't unselect it, but it doesn't allow you to go back. So there's just a bunch of weird stuff that I think could be better in mobile. So those are the things I'd like to do. I'm in my development directory. I have set up Pi so that it's got access to these different models. I have, like, a bunch of these models already configured. So I can do -- model and say Kimi K3. Let's do K3 for, actually, yeah, let's start with K3, because K3 is like the most capable model. You can see I've also got DeepSeek V4 Flash set up. Let's do K3 first. Oh, this is Pi, the Pi coding agent. We can tab between low, medium, high, and max. So let's do max. Why not? Okay, I'm going into the NeuralColumn. And this is a standard Pi installation. I don't have any extensions. I don't have anything. I'm keeping it completely plain for now. So let's think about how to break this down. Since K3 is the best at like the coding and styling and website portions of things, this is the one that I want to, like, do to figure out the style. First, I want you to read and deeply understand how styling works in this app. Once you're confident that you can easily handle my development requests as it pertains to styling these documents. So it's going through, it's figuring out what the CSS looks like. In the meantime, while that's going, let me start a new document, make it a lot bigger so we can read. And I'll even get rid of this Explorer. Okay, I'm going to be working on the prompt that I want to send next. So I have a few problems with styling right now. One, sometimes I have noticed that the styles that I see in the preview are different when it's in design mode and when it's in text mode. And I'm going to do word wrap so that we can see everything. Let's please normalize this so that no matter which mode you're in, you're seeing the production style, the latest development styles for that document. Number 2, I edited a style of a document that had already been published. I noticed that as I was editing style, it was also updating the published artifact, which is not what I wanted. I was hoping to be able to develop and iterate on the style and use my judgment, and only once I was happy with the result would I republish the document, and only once republished would it show the updated style that I had been developing. Let's make sure that we have these two things separated enough in the code so that publishing bakes the styles into the published document, and then further edits to the style by definition do not affect the published document. Number 3, I would like to actually be able to see the style sheet and be able to manually edit it if I want to, or at the very least be able to understand the edits being proposed in the style agent. Right now, I can apply it, visually inspect, and either decide to keep or discard. I can't actually see the code that's changing in the style sheet. I would like to be able to see and even edit this style sheet, given that the agent is already doing so. This is Kimi K3. This is the open source model. I've just given it 3 different separate problems that I have, and let's just see what it comes up with. This is near the top of that design arena. Let's see what it can do. A lot of thinking. I absolutely love that with these open models, they don't hide the thinking from you. You see exactly where they're going with things. So if this starts going off track when I'm like in the flow of things, if I'm using the coding agent directly, which I'm using less and less these days, a lot of what I do is like building a product requirement and then like tossing it over to the agent. But when I'm actually coding with the agent itself, it's so great to be able to look and see what it's doing and potentially stop it and say, oh, no, I want you to go this other direction. Or, oh, no, or yes, like that's a great point. Go and like zoom in on that, It's so nice with these open models to be able to just do this. But we're still going through, it's doing a lot of thinking, which is cool. It's actually thinking about each of these problems in turn, which is cool. It's very instructive to be able to see what the thinking process is. So it's going through and starting with problem 1, currently like stating the current situation, coming up with, okay, this is the fix, but wait, and you'll see these sort of specific turns of phrase where in the thinking you can see that it's gone off on some path and it's thinking, but wait, and oftentimes it'll go on a different path, but sometimes it'll just say, but wait, have I considered this? Yes. Like, and often it'll be confirming what it's already thinking. Another one is, and I don't personally know if they're explicitly training these pivot tokens. Some people call these pivot tokens, where like the entire thinking kind of turns on this, like if you're going in a wrong direction and you go, actually, and you get on the right direction, that can be the thing that takes a trajectory from something that would fail to something that passed. So so what this is saying is it's giving three options. Option A, always use the server iframe preview. I kind of like that. Lose scroll sync. Oh, okay. It's considering the scroll. Option B, apply the document's theme to the client-side writing preview. Keep the fast incremental preview, but style it with this document's theme CSS. Problem, the theme CSS is written against the markup contract. Interesting. So they're saying, okay, we have a different contract for well, that's bad. Like, we shouldn't have that contract. What is this saying? Okay, B3, use the shadow DOM. Put the preview in a shadow root with the theme CSS inside. Shadow DOM gives perfect style encapsulation. And then the app CSS doesn't leak in. Actually, wait, could the server do the rewrite? No, the theme is stored canonical and shared with the agent. Okay. So this is kind of leaning towards this shadow DOM concept. Option C, keep two previews, make them use the same styles, i.e. extract the theme into the client preview via a style element in the pane. So, okay, it's choosing the shadow DOM. Fine. Shadow DOM sounds fine. So in the meantime, what let's do is start talking about some of the news items. We've got OpenAI and Anthropic both hacking. So OpenAI hacked Hugging Face, and then they're now partnering with Hugging Face to sort of figure out what's going on. I just want to bring this up because it's an important thing that happened in the industry. It's driving a lot of people to think about policies that should be done to address this. My personal opinion is that I have always said that you should be able to train a model that's as powerful as you want, that's as capable as you can make it, or as capable as you want it to be. But the second you take that model and load it into into a harness and run it, that's when I think like you need to start thinking about liabilities and start thinking about fault. If you're inferencing or if you're putting it in a harness to like run as part of a training run, that's still a deployment. That's like a running version of this. I think like if you look at the weights themselves kind of like are no big deal. The weights can't do anything by themselves on their own. But as soon as you load that into an inference harness and start inferencing on it, that to me is something where like if you misconfigure that and it goes and does a bunch of damage, you should share some fault in that. That's my personal opinion. So we're starting to see this happen. And what's so infuriating about these stories is that it sounds like the labs that talk a big game about safety and talk a big game about like making sure that other people don't use their models in dangerous ways are deploying their own models in very unsafe ways and are not doing some of the most very basic security practices. Like when you talk about a sandbox, for example, in this one, it looks like they put it in a sandbox that had access to the internet. In all cases, Anthropic's evaluation prompt specified to Claude that its environment was a simulation and that it had no internet access. Due to a misunderstanding between us and our evaluation partner, this was not the case and internet access was available. So what this is saying is that this wasn't a sandbox at all in any sense of a sandbox, or at least it wasn't some of the most basic dangerous capabilities were available inside the sandbox, meaning the sandbox wasn't very useful as a sandbox. And so this is one of these situations where this was an unsafe deployment situation. This was an unsafe deployment environment. And the same with this. This was an environment where they clearly they did not have in place the monitoring that they needed to detect that this was happening. there were so much activity that was going out through the network on this that, like, if anybody was monitoring it in a reasonable way, they would have caught it. And so these are two situations where the companies that talk about this the most, and the companies that are raising this issue and saying that you can only trust us because we're the responsible parties here, they're not doing table stakes security hardening. But as soon as you load that into the harness and start inferencing, I think that's where you bear responsibility. And so this is just my opinion. A lot of people at the leading labs and some of the people from some of the open labs as well have signed this statement saying that, hey, we're scared about all this stuff and we don't have the capability of telling everybody to turn it. We don't have an off button for the whole industry. So please, government, develop one. And they don't say it, and they're very careful. It's it's a carefully worded statement that they're not requesting a slowdown. They're not requesting a stop. They're requesting that the governments of the world figure out how we could stop, potentially. I think this is ridiculous, personally. I think that there's just no realistic way that anything like this could ever happen. And even if it could, I don't necessarily think that it would be a good thing. There's no version of this that I could see where it doesn't just give the government complete power over all of us, over everything, over our ability to think. But there are a lot of people who are very concerned about this. And I think what a lot of these people are saying is that, like, we need to signal, signed because this statement helps to establish common knowledge about the possible, like, they're trying to signal that if something were possible, we would be supportive of it. And this is a minority of the people in the labs that have signed this. I'm raising it because it's a thing that happened in the industry. And whereas previous statements of this kind did not get the caliber of signatures, like, we're looking at very important people in the world of AI who have all signed. A lot of them have signed up on this. So it's not something you can totally ignore. But I don't think anything will come of this. I actually hope nothing will come of this, because if it does, anything that I can think of where governments would come up with these pacing dials, that anything that they come up with is going to be, can lead to totalitarianism. So I'm concerned, but also not too concerned because I don't think anything will come of this. Why are people getting kind of nervous about this? It's because things are progressing. Last night, or yesterday, August 1st, OpenAI published this paper that says that 10 previously unsolved challenges in mathematics were solved. 10 different ones. These all do seem to be real, legitimate, strong advancements of math. What does this mean? It just means that the progress that we're seeing in all of these things, like the progress, you go back and you look at the Inkling-Small post, like this, if you look at this one, it starts to level out a little bit. This one starts to level out a little bit. But you can easily see that just by pumping more into this, we're going to get better models out. And math is one of the most verifiable, easy things for us to do this RL process on, because there's a truth. There's a true answer for every math problem, or there's a set of true answers that can be validated. And so math is just like coding and math, but math particularly are getting conquered by this. And I think what we're seeing is a lot of mathematicians and people trying to figure out what does this mean for us? How do we climb up the ladder of abstraction? What's the higher level than resolving math conjectures, or coming up with new conjectures? Actually, that's interesting. So far, the models are not coming up with new conjectures that I know of, but they're solving a lot of the ones that we've come up with already. So the result itself is incredibly impressive. The second thing is that this also talks about a new model class. This is not necessarily saying This is GPT 5.6 or GPT 6. Maybe it is GPT 6, but they're saying that, we have a Luna, Terra, and Sol class of models right now in GPT 5.6. This is saying there's an Astra, there's a higher model class. To me, this is telling me that OpenAI is going to release a model that's as big as Fable is. So whereas like with Claude, you have these 4 different model classes, and in OpenAI, you've only had 3. This is saying they've got a 4th one. It's under training. And look, it just solved these 10 unsolved problems in math. So that's really cool. It's probably the largest model of their new GPT-6 line. And they're coming out and talking about it already. So so the results themselves are impressive. What it signals to us about the scaling of these models is also impressive. And like the cost is also pretty impressive too. That these solutions would have only cost $2,000, and they are saying that that's at Sol prices. So I don't know. I don't know if that's an apples to apples comparison, but it's clear to me at least that this is going to continue. We're going to continue to get more and more stronger results, especially in math. And so it's good that this is kind of starting the conversation about what are we going to do? What will people who have been thinking about these problems move on to next? And how can a mathematician who knows about and who can guide these models use them to then further our understanding of math? Like, in my opinion, it would be so cool if mathematicians take this and then apply it to like the Langlands program, or I don't know, like what are these big open questions that we have about the connections between different mathematical branches and how they could potentially connect in certain ways. I talked a lot about GPT 5.6 Luna compared to DeepSeek V4 Flash. And DeepSeek, it's pretty clear that GPT 5.6 Luna and the new DeepSeek V4 Flash are reasonably similar. When you look at their, like, we looked at their numbers before when they were on the benchmarks, they're pretty much trading blows at maximum reasoning mode. I don't really know how they compare when you lower the reasoning mode, but at least at maximum, they're pretty much hitting the same heights. And before, it was not this cheap. But what this blog post is saying is that they cut the model cost by 80%. And they made it much more affordable. And this is quite a good Pareto frontier buy. 5.6 Luna is a very good model. It's a good model, not necessarily for planning, not necessarily for like your high level organization or orchestration, but for like if you give it a task and you give it bounds and you give it a good description of what you want it to do, it can just fly. It goes fast. It's very good at instruction following and heeding and adhering to those instructions. And in general, it's just a very good model. And it's at good prices now. I mean, but dropping it by 80% is a massive reduction in the cost. And you've got people talking about matching intelligence to the outcome. You should use different models for different things. 5.6 gives you more room to optimize the cost equation side of the equation. And, talking about how they measure it and how they match it. But really, I think this is kind of like they're trying to match what the new Pareto frontier that now DSV4 Flash operates on. I actually think this is a great article by Zuckerberg. It, I believe, is one of the more optimistic takes on the future of this AI stuff. It's also, I think, personally realistic. And if this is the direction that Meta is going in, I'm excited about it. I'm actually going to read this because I think it's reasonably short, and I want to give my take on it. And it feels like pretty much aligned with what I believe. So let's just read it out and we'll kind of react to it. We are fortunate to live in an incredible moment in history, In the next few years, people will be able to use superintelligence beyond human capacity to create and discover extraordinary new things, build new businesses, express our ideas, learn new concepts, and improve our lives, health, and relationships and careers. The defining question of our age isn't whether superintelligence will exist, but who will have access to it. Will it be centralized and restricted to a few institutions, or will it be a tool that empowers everyone? I propose a philosophy based on individual empowerment as the source of prosperity, invention as the primary purpose of superintelligence, and balance of power as the foundation of safety. It is surprising that the discourse from many of those who are developing artificial intelligence is so filled with doom. I don't understand why anyone who believes that AI will eliminate most jobs and much of humanity's relevance would rush to build that future. The notion that AI is so dangerous that the only safe path is an extreme concentration of power seems dangerous. Historically, hoping that an absolute power will benevolently provide for humanity, if sufficiently enlightened, hasn't led to safe or positive outcomes. Humanity has witnessed many transformative advances. Each time, there is fear that people will be left behind. But each time, humanity has come out with more people sharing greater prosperity, health, and freedom. We believe this will be true with AI as well, and the abundance of the future can be shared by everyone. We also believe that the values that got us to this point, liberty, open inquiry, free enterprise, and equal opportunity, are also the values to build a positive future. Putting power in people's hands to pursue their own aspirations is how humanity has made the most progress. Novel ideas and major steps forward rarely originate from the established institutions alone. They came from brothers in a bicycle shop who believed people could fly, the bookbinder's apprentice with no schooling who figured out how to generate electricity, and the kid in a garage who thought personal computers would be for everyone. We believe this will continue to be true. As everyone gains more powerful tools, each person will become more capable of shaping the future, not less. Invention, not automation, will be the greatest contribution of superintelligence. Early AI could answer questions and do routine work. Soon, it will increasingly help discover new knowledge, from discovering new drugs to cure a family member's disease, to finding new ways to improve your business. While the number of questions you can ask in a day is limited, the number of valuable things superintelligence can invent to help you achieve your goals is unlimited. As intelligence becomes abundant, the most important question will be how we direct it. Some argue that superintelligence itself, or a small set of experts who control it, should decide what is best for humanity. I disagree. The history of democracy and economics has shown that there is no single objective answer to how people define the best life, and therefore the best approach is letting people decide what matters to them. Rather than centralizing power, we believe that delivering personal superintelligence to everyone is the way to answer this question. This has the potential to begin a new era of personal empowerment in which individuals have greater freedom to pursue their interests and reach their full potential. Healthy societies also recognize that safety requires checks and balances. If only a handful of institutions have superintelligence, they will inevitably exercise a controlling influence over economics, science, and politics. Even with the best intentions, that concentration would limit people's ability to choose their own future. As a thought experiment, imagine only one person had a superintelligent lawyer. He would have an unfair advantage in court even if his position is wrong on the merits. That would lead to a worse society. But now imagine everyone has a superintelligent lawyer. Justice would be carried out much more fairly and efficiently than it is today. When people are empowered, they naturally check and balance each other and the power of larger institutions. Most societal questions can't be solved by attempting to align a single benevolent superintelligence. Humanity isn't a monoculture. There is no technological solution that can align with everyone's opposing interests and diverse values at once. Any singular superintelligence would have to prioritize some values over others, and in the process would be incapable of being benevolent to everyone. Many risks require serious attention. In most cases, like cybersecurity, the history of open source software has shown that giving everyone full access to powerful systems will be the best way to protect safety and security over time. For other risks, including biological risks, more coordination between governments and other institutions on responsibly deploying capable models will be helpful. This applies to the economy and to the future of jobs as well. There is a balance between the use of AI as a tool for automation versus as a tool for empowering the people to expand their skills and build new businesses. If the balance leans towards automation, the impact on jobs and the economy may be negative. But if superintelligence is widely distributed, then I believe we will see more jobs in the future, not fewer. It will be significantly easier to start businesses without raising large amounts of capital. I expect the economy will become more entrepreneurial with greater number of people working at small businesses rather than large companies. Developing superintelligence will be the most profound technological advance we will see in our lifetimes. Meta is committed to building with the principles of individual empowerment, invention, and balance of power. The arc of human history has bent toward more power in people's hands. If these values lead the way, then I am optimistic that we can build a positive future for everyone. So, what do I think about this? I basically agree with almost every aspect of it. I am surprised by people being so doom-filled about all this stuff. I think it's a lack of imagination to think that the current jobs, which will be automated in many cases, will not scale. I also think that there's many jobs that won't be automated. If you're an influencer, if you're a chess champion, if we already have computers that are better than the best chess players. Chess players are obsolete, completely obsolete. But why do we still watch them? Because we care about their human stories. We care about like humans getting better at this. We care about the narratives about who's an up and coming person and who's losing. We care about the personalities of the people involved with it. So there's all these human narratives that like we simply won't automate all the jobs out. But there are plenty that might be automated out. But it's an absolute failure of imagination to think that there won't be new ones. Many new companies won't be created. That many new entrepreneurial ideas won't be explored. And I do think that like this concept of like giving everybody a super intelligent lawyer, it's absolutely right. If only one person had a super intelligent lawyer, they would use that power to get out of whatever that they were in being accused of. Like even if, like this says, even if their position were wrong on the merits, they could use it to just get out of it. It's a get out of jail free card. If you have one person with a super intelligent lawyer, they would always be able to find some loophole or some advantage or some reason why they could get out of it. It would be a bad thing. But if everybody has a super intelligent lawyer, it doesn't just mean that within the context of the system, they're all going to be good. But if you think it through, it would absolutely improve the entire justice system. Like the entire system would be better because everyone would be finding all these loopholes. And then we either patch the system, we do it faster, or, like check each other. And you can just imagine all the ways which it would improve the system. The argumentation would be so much better. Innocent people would be free more often, and guilty people would be prosecuted more often if every single lawyer were super intelligent, I think. And I do think that absolute power corrupts absolutely. So these companies that are trying to argue for either a government having that power or an individual company having that power, I think it's very fraught. I also agree with the cybersecurity thing. Like the worst thing we could possibly do is what we're currently doing with cybersecurity, where we have these powerful models that some people can access, but then like we're not giving people access to the defensive capabilities of it. We're only giving offensive capabilities to like friends and family type thing. It's like the worst possible situation. Whereas if everybody has access to this and we give it out as widely as possible, then we all have the capability of hardening our software. And if you don't, then that's kind of your fault. It's like part of the job is to be hardening our software for cybersecurity. There's nothing about AI that invents these flaws. The flaws are in the software now already. There are bugs. Now, biological risks are the one area where I don't know. I don't have enough information to make strong arguments. Cybersecurity went so far in saying that people should not be given access that I'm skeptical about the risks here too. The people who know what they're doing said the same thing about cybersecurity. Is it possible that we could scan for all of these at the vendor level? That the biological artifacts that you need to create dangerous things could be monitored themselves instead of the models that teach you about how to do it? I strongly worry that we're not going to be able to train out the biological knowledge in a good enough way that we can reduce all these risks to zero. I think there's just going to be it's really a knowledge risk because the knowledge is part of the universe. And so trying to prevent people from having that knowledge seems like a losing battle. As humanity gets smarter, we're going to find the AI is just the first way to access this knowledge potentially. So we need to figure out what a more defensive strategy is going to be on biological risks. It doesn't involve just keeping people in the dark. I don't believe it. This is the one risk though that I am more open to considering. There's a possibility that there's a cheap, abundant way of making very biologically dangerous things. I hope it's not possible. I hope that we can just monitor all of the ingredients. But Meta is working on this their own model called Muse Spark 1.1, and I wanted to just bring this up because for a while you couldn't access Muse Spark except for directly through their API. But a lot of people don't want to make a special integration just for one model. Like there's only one model that's even available on this. It's only Muse Spark. So adding that whole integration just for one model, when the model isn't winning any competitions, it's not really a lot better on the capabilities front than anything else. And if you look at it on the cost front, for a while it was the Pareto frontier, but now the new models from DeepSeek and with the lower cost of the Luna model from OpenAI, this is a lot harder of an argument to make. But that being said, it's available on OpenRouter, and that's pretty exciting actually, because it means that it's like you can actually use it in your products today. So that's pretty cool. And the throughput's not too shabby. Again, the price is no longer competitive with current things. And it's crazy because it was just released half a month ago. But that's how fast things move. It's 9 in, 18 out versus $1.25 in, $4.25 out. It's just not even competitive anymore. It's just not even close. And we're at pretty much the same capability level. A little bit better for DeepSeek than it is for Muse Spark, but not enough better to make it that price difference. That's an insane price difference. It's hard to even think about it. But for a minute, this was the Pareto frontier. Ooh, also, this model is only available to users in the United States. I didn't realize that. That's terrible. Okay. Meta has some stuff to do. It's actually doing things now. You can see it's actually making changes. CSS lang. This is probably so that we can actually edit, and it's going to give us nice syntax highlighting on our CSS. But look, it's going. Look at all these changes. Like this is all from that one prompt that I did, and then this many tool calls later is still working, but I haven't had to intervene or do anything. I guess let's talk about more news. Another thing that has started to happen is that I think people are starting to realize that skills can be debt almost immediately. They're saying with Opus 5, literally just delete all of these things and see what ones you still need. A lot of people started on Opus 4.5 or Opus 4.6 at the end of last year, and those models, while they were very powerful, they needed a lot of guidance. Like even Opus 4.5, even Opus 4.6, it didn't have enough contextual awareness to know when it's opening a PR specifically how to act or how to match the surrounding before and after PRs, or how to like use the context of the code itself to see the style of the code it should write. There's a bunch of these behaviors that you had to kind of like say, okay, when you're making a patch in this part of the code base, make sure that you like follow the conventions of the code around it. A lot of people have like PR skills where it's like, when you're opening a PR, make sure you look at the preceding and following PR, or the preceding PRs, and make sure you're matching the styles. Like these are trivial examples that I'm coming up with, but with Opus 5 and with some of these newer models, they've baked that in. They've baked in these popular widespread behaviors into the model. They've basically distilled a lot of people's skills into the model itself. And so themselves, they were noticing that they could drop the prompt that they use in older versions of Claude code versus the prompt that they're using now. It's massively shrunk. It's a lot less. And this is good in a lot of ways, because every line of code that you have in your Claude.md or in your skill.md, it's another surface area for potential disagreement. And every new line of code that you have in your skill.md or in your Claude.md is another potential, like, you have to think about, like, when a genie grants you 3 wishes, you have to think super carefully about each of those wishes, because how could they be interpreted, or could they be worded in such a way that, like, it does something that you weren't expecting. I think that's the way you have to think about your Claude.mds and your skill.mds, where you need to qualify everything down. And I think people have not been routinely doing that for everything. And so they have these lists of instructions and requirements and this list of stuff that has grown over time and was required for older models, that newer models, which are better and are even better at instruction following, they have to sort of decide when conflicting instructions are given, which one wins in which case, and it makes it think more. And they were saying that as they deleted a lot of these instructions, the thinking went down and the quality of the outputs went up, because a lot of it was just built into the model now. So no, you can't like delete everything. If you have specific functionality that is just completely non-standard and you need it to be that way, you have to put a Claude.md or you have to put a skill.md somewhere. But I think what the advice is coming out to be is that for a lot of things, you don't need it. Okay, let's check back in with our code. So we talked about these changes that I wanted to see, and now it says it's done. Okay, so it says there's a clean build. Okay, so this is saying there's like a pi directory, there's a pi current working directory, and then there's a temp. Okay. And npm run dev. Oh, wait. The agent turns will answer the agent could not be started locally until pi is laid out the way the image expects. One time setup per machine. Okay, I'll do this. Create that. Create some node modules and link them in. And then, oh, it's got an extension. So, okay. We'll do that. And then I'll start the backend. npm run dev 5173. I don't remember what I put for my password here, but hey, looks like I saved it. Let's check where your local server is pointed at. Oh yeah, because it's talking to the production B2 bucket. That makes sense then. Not a copy. Edits from your local dev server right to the same bucket production uses. Okay. Versioning on the bucket creates versions, so it's recoverable, but publishing from local would overwrite the live public page. There's no separate dev environment namespace. That's fine. You know what? That's fine for now. It's still text preview split. Let's like save reload. Okay. And by the way, we have history, so I can like see what changes were made. That's kind of cool. That's before. I've got this like CSS or the page, or I can do the split. You know what? I'm starting to like this like design versus text thing more than I thought. Whereas here, this is the CSS. I feel like the highlighting is all messed up though. It's actually okay. I feel like the syntax highlighting is messed up here. Actually, you know what? I'll just tell it. Okay, I said it's messed. See, this is why it's good to see the thoughts, because like I said messed up, and it's not finding that precise enough. Like it's saying that's not messed up per se. That's just minimal. And it's like, okay, actually, I wasn't very precise. Let me see what the CSS editor is actually getting right now. The laser CSS tag vocabulary versus the 2 highlight rules I gave it. I was going to try and take a screenshot and send it over, because we know that Kimi K3 does have a vision encoder, but the problem is that this is running in WSL, and copying it into WSL might be annoying. I'm just going to see if it can figure it out. Now I can see the full tag vocabulary. My editor highlight only covered string, keyword, and comment. And note, comments in are block comment, not regular comment. So my comment rule doesn't even fire for CSS. And t-string, CSS strings are t.string, t.keyword moves from selector, scope, match flag. Okay, so it's saying it's kind of it's figuring out that it's got deficiencies in simple, principled. I don't know. I really like being able to see the thinking. The picture is clear. Laser CSS emits a rich tag vocabulary, and I gave the CSS editor a highlight style with 2 rules that cover almost none of it. So nearly the whole style sheet renders as plain text. It's also using the prose sans font, which is wrong for code. The bigger, undeniable issues. I didn't have to say anything. I didn't say anything. This is just like, honestly, the power of Kimi K3. I just sent it an image. It read the image. It's like figuring out that there are problems. It's reasoning through how it can fix it. Maybe I'm misreading it. Nope. Too much orange, hard to read structure. I would basically agree with that. Too much orange, it's hard to read structure. Like, why did this get orange? And like font size, like why is the EM orange and not 0.875? I don't know. In general, it's just not, it's not a helpful syntax highlighting for me, in my opinion. It's doing stuff. It's reloading, or at least it feels like it is. That's very helpful. I can see exactly what's wrong. Far too much orange. That's tag inheritance biting. Okay. OpenAI trained their models, their latest 5.6 model, on Codex. And Codex takes advantage of all of OpenAI's platform features. One of the platform features they offer is a server-side compaction. You can literally just take the compacted version and try and run it out and see if it gets to the same verifiable rewards. If it doesn't, then you have like something to reinforce. So when they did this benchmark, when they released GPT 5.6 Soul, it was a little bit of a bummer because they didn't do a whole lot better on the ARC-AGI 3 results. Like if you looked at the official harness results, it was like they did do better. It got better with more thinking. And this is, I think, better than it was previously. I think previously we were at like 6 or 7%, something like that. So this was an improvement, but it felt like a bit. There was so much of a leap in the model, and when you're using it through Codex, you feel so much like there's so much more power than there was in 5.5. That this didn't seem to really match our experience. There were 2 things. First of all, it did not include the reasoning traces in the next messages, and also it didn't use the compaction situation. It didn't use the compaction endpoint. It helps if it can see that thinking in the next message that it sends. And then once you hit that limit and it compacts, if you use the compaction endpoint and do and use the real compaction stuff and then continue from there, the compaction now has like a good compressed summary of the reasoning versus imagine just like discarding this old reasoning stuff and this old user prompt and just leaving like the latest end messages. That's clearly going to be a lot worse. And so that's basically it. They found that when they plugged it into a harness that looked more like what they train on, they get a massively improved score. That's a 38.3% score. When Opus came out, things started to seem a little fishy because it's like, okay, when you're using these 2 models, Opus 5 doesn't feel that much stronger than GPT 5.6 Soul. And it could be just that this they weren't training to this particular use case, or like GPT-5.6 Soul is different in certain ways. So maybe it doesn't have as much reasoning. But you look at the heights that it was able to achieve here, 38.3, that's doing even better than Claude Opus. We're talking about like it's up here now, and that's 5.6 Soul. So it just shows, and by the way, the Anthropic harness seems like it was prompted in the exact same way as this was. So this is fair, and that's why this hasn't been updated, because every single model does not get to customize their harness. They all have to be put in the standard harness and put through the standard way. I think it would be interesting to have a version of this where like Claude is given Claude Code and GPT is given Codex. I think it would be a lot tighter and a lot higher of a graph. By the way, this session, Kimi K3, not expensive, but also not cheap. It's been $6.50 so far. It's done a lot of thinking, a lot of tokens spent to think. So there's been a lot of tokens, and you can see we're on, what is it, 18.5% of our 1 million token budget. So we haven't even made it up into the million, close to the million mark yet. I should switch us over to DeepSeek V4 Flash soon, but let's finish some of the CSS styling things first, and then I'll switch over. But it's going to be a massive jump down in cost and maybe a minimal jump down in quality. There was a pretty cool thing that happened, which is pretty exciting, which is this post by Alexi Gladstone saying, we have discovered a third pre-training axis beyond parameters and data. We just saw with Kimi K3, it got up to 3 trillion parameters. And that's like one consistent way that if you just increase your model size and send the same amount of data through it, or maybe even less, as the model size gets bigger, like, okay, if you fix your data and you keep increasing your model size, your models will get better. If you fix your model size and you increase your amount of data and you just keep sending more and more and more data through, your model gets better. So we have these two axes right now where whether it's the amount of parameters you have or the amount of data you send through, that those are your two major axes for how good a model can be. There's a little bit of a third one, which is inference performance. We've talked about that. About how we talked about with the K3 stuff, about how because they're making it faster, they're making it more efficient to do forward inference, that they can do more training runs, they can get to the end of the trajectory faster, and they can reinforce that and get to a better model faster. And so having a smaller, more efficient model, when you get into the RL stage, can actually like hill climb faster. That's a little bit of another axis, but what they're finding out here, and it's kind of along that same line, is that they found this third pre-training axis, this idea of quote unquote exploration. And their numbers are really incredible. Like their numbers just show that like by adding these modes of exploration, they're able to drop their loss numbers by quite a bit. And it is a trade-off, because you have to, by exploring more of the generative model space, you have to do more inference, you have to do more forward passes. In fact, they have this blog post. Here's like kind of a good quick pseudocode explanation of what this idea is before, without exploration, you would just like sample the latent space, send it through the model, you get a Y. Y is your output, whether it's like an image, whether it's a chunk of tokens, whatever that is. You sample from some random noise, you send it through your model, and you get your Y. This is, but to be clear, this is mostly useful for like diffusion models and for flow matching models and for the image generation stuff and audio generation stuff. It's a little bit less useful for the token, the LLM type stuff. But let's think about images here. You start with noise, you send it to the model, you get some image out. Now, maybe you have image text pairs, and you have like some image that you were trying to get to from this text pair, and you can say, okay, what's my loss? How far away is the image that we generated from the image that I asked for? And then like based on, you want to minimize that loss. So when you run this backwards pass, you do this many times, and that loss is gonna go lower and lower. But this new idea is just a very, very, very simple change to the existing idea. The old one is just you sample, you run it through, you look at your loss, you minimize your loss. All this is saying is that instead of just sampling once, you sample a bunch of times for the same idea. You sample a bunch of different times and you see which time went through and was lowest, which time was the best. And then you go backwards through that. An important part about this is this min. So you're doing a bunch of different loss functions. You're doing a bunch of forward passes through your model, and you're keeping all of the losses, and you're finding, you're saying like, how far away is this from this image that I want? And what you do is you only take the lowest one. You take the one that resulted in the very lowest loss, and you use that as your backwards pass. And this is the same thing. This is just saying that, like, for a diffusion model, you'd sample your time step, which is like, how far are you into the diffusion process? And then for each one of these things, you sample some random noise, you add your noise from your data level, and then you figure out your diffusion loss for that one thing, and you add that into your losses list, and you find the one that created the very lowest loss, and that's the one you send backwards. They have a whole paper out on it, and it's pretty exciting. It does seem to be a new axis. And if you look at some of the things that were like some of the qualitative differences that come out of it, you see that like it's able to really sharpen and change some of these different distributions. The distribution actually really does change. With no exploration, you're not getting these three different, you're just getting this clustering. And then even just with 2 exploration steps, you're starting to see more diversity here. And then once you get to these like 50 exploration steps, you're getting to a really good, really strong representation of the underlying data set. So the way that language models work generally is 1 token at a time. Like causal language modeling is when you go to GPT and it runs, you're asking a question, it's doing causal language modeling where it's masking out all of the next tokens, like all the tokens beyond it, and it's looking at all the tokens before it, and it's generating 1 token, and then it looks at all the tokens before it and generates 1 token. It's another different style of language model where instead of that, you have a chunk of tokens and you mask out certain ones. It could be in the middle, like maybe you have the later things, but you zero out some of the ones in the middle, and you want your model to generate those tokens all in the middle. That's this masked diffusion language modeling concept. And this applies more towards that than the causal language model. And so far, those other ones, this type of masked language model hasn't been as successful in the industry. So this is an improvement on that type of thing. We will see in practice if this technique takes that masked language model to like new heights beyond what causal language models has right now. So far, that hasn't happened in the industry, but we'll see. It's actually kind of like an older way of doing language modeling. Well, it's older and newer. Like the masked language modeling part is older. The diffusion style is newer. Yeah, like if you think about like BERT or some of the older models like that, that was oftentimes using the masked language modeling, but not diffusion necessarily. So diffusion is kind of the new one, and we'll see. I mean, that's also how some of the like DSpark works. So this would actually be a way of potentially more quickly training DSpark implementation for speculative decoding. That would be pretty cool. Real problem wasn't token colors. It's 2 structural, faint punctuation, true. No hierarchy within declarations. Okay. So I know I should just trust it, but I don't. It's all looking like line noise because it's optimized to minimize file size. I'm not terribly worried about file size this day and age, and with the amount of CSS we'll be right. I'd like you to gridify or beautify this code and make sure that when we're editing CSS, we're seeing a nice ergonomic version of, or it will reduce the pressure on the CSS styling because the space arrangement of the text on the screen will be easier to visually parse. And I think this is like all comes from the fact that when we vibe coded this first, you weren't seeing this this style. So like, yes, this style existed, and yes, like there's a this is like a default style that gets applied to all different new documents. It was this hidden thing that wasn't being shown, and now that this is a first class feature of this editor, is that you're seeing the CSS, you're editing the CSS, you're doing all of that. It makes it more interesting to make it nice looking, ergonomic, with good white space and all that other stuff, like CSS file, rather than just everything on one line. That third pre-training axis was really, really cool. Here's one that I don't even know if I fully understand. I was asking GPT to explain it to me. But I think it's an interesting exploration of potential optimizers. So what this is saying in defense of the quadratic model, what my explanation of it is that as you get past some point of pre-training or training, models start to become very predictable in the optimizer space, where you can basically take a look at the trajectories of the optimizer and relatively accurately predict where those gradients will go. And basically it's quadratic. And the idea is that locally, if you look at like the next 100 training steps or some small amount of training steps, you can very accurately use this, you can fit to this curve and say, hey, it's going to go this way. And then beyond that, yeah, it starts to diverge. So you have to constantly be updating. But in the local areas of this optimizer, you can very accurately depict where it's going to go. And so it's interesting because like you could imagine a future optimizer that takes advantage of this property and says, hey, let's skip all the intermediate steps and just jump over to there. We already know where it's going. Like we already know the curve it's going to follow. If you can, and so if we can quantify the amount of like shift from short to long, we can build an optimizer that like optimizes and does way fewer steps, like basically jump ahead to step 50. And then as long as we don't jump too far ahead, you're not going to be too far off policy. You're going to be pretty on track. And so that's not what this is. This is not the new kind of optimizer, but this is understanding the predictability of the process and understanding that like at these relatively small, but not too small levels, you can reliably predict using these quadratic using the quadratic fit. So again, I am not a mathematician and this is beyond me. I was asking GPT to help me explain it. But yeah, let's take a look here. It says, how well does the simplest model in optimization theory, the quadratic, accurately describe LLM pre-training? Surprisingly well. We linearize a 150 million parameter model at checkpoints throughout training, and the local Taylor expansion tracks the true loss for up to 10% of the training budget. So like 10% of the training budget is actually, when I said like 100 steps or whatever, like 10% of a budget is huge. That's huge. Imagine that you only had to do full optimizer steps like every 10% of training. That's crazy to me. And look, what they do say is that it has to be later on in training. Earlier on in training, you see it diverges right away. But as we get closer, like, look, this is right on target. Basically, it's right on target. So that's the cool part. That's the thing that they're saying here. Anyway. like I say, I'm not a mathematician. I don't have strong intuitions on the quadratic model or anything like that. But it seems to me that this will lead to some optimizers that are more optimized than current. And specifically, by the way, they did analyze Atom, the Atom optimizer. I just think it's interesting, and I think there's going to be future work that builds on top of this. The stored form is now always the formatted form, so every reader of the style sheet saves the same ergonomic bytes. So this is like having it think about security from the beginning, as long as it doesn't like prevent the features that I want. Like I do want to preserve comments. If we have comments in there, like comments are good. It's helpful for understanding code. Like I think comments are something we need to support. So our safety pose can't prevent features like comments from existing. It's just that how can we build the feature in such a way that it's safe and also comments are allowed? I never said before when I was talking about the requirements, I never said anything about comments. So it just figured I didn't care about that. Now I'm specifying and I'm saying, hey, comments are important. We need to preserve them. This is a practical test for session ownership. By a portable session, we do not mean that switching from one model to another must produce the same next token. That's a given because models have different capabilities, trained personalities, context windows, and ways of working with tools. And well, it's all quite non-deterministic anyway. Portability means something more modest, which is that you should be able to call session.export, save it in a transcript, you revoke the credentials for your old provider somehow, and then you have a new provider where you continue from that transcript. So does this transcript carry all the information that you would need to continue the conversation? That's all this is saying. And that it's becoming harder and harder for this to be true because of a couple different things. Number one is, and by the way, yes, like this is good for your sovereignty or for like the ability to transfer from one to the other and not be locked into a provider. But it's also good that you like by having this, it means that you have everything available to you that you need to inspect and look at what's happened in that transcript. So like if there's stuff that's hidden from you, that's stuff that's also hidden from your analysis. Like you can't go back and figure it out. So like they're talking about that as the audit. And it also there's also questions about whether if you don't have a nice compact transcript, can you like delete the other stuff, or is it like scattered throughout the architecture in the system? I think another aspect to this that kind of comes out is that it's really good for the model provider if you can't do this. If you can't just go from one to the other, then not only can't you, like there's a bunch of tokens that you can't see, like thinking tokens. It also means that you're kind of stuck with them. You're like locked into this provider, at least for this session. So that's not necessarily great. So the incentives are not aligned for the model companies to do this. And this is what they're saying. It's like reasoning tokens. These tokens that you're being billed for them, but unless you're using an open source model like we are, you're going to be billed for them, but you're not going to be able to see them. Also, web searches, where the model sees the results from the web search, but you never see what the model saw. You never see what in your transcript, like the results. That's like hidden from you. Also, if you do compaction, and then it encrypts the old version of it, where you're seeing these opaque tokens, but it's actually a compact version. That sucks. They've trained this, and so they don't want you to be able to distill their compaction, but who cares? Like, you actually also need to be able to see your own inference. You can't, if you have an encrypted context that's like the beginning of your conversation, there's no way you could port that over to another one. The other thing is like sub-agent instructions and messages, where there's all this stuff that's happening between sub-agents and in the sub-agent that doesn't necessarily make it into the transcript, and then you can't go back and figure out whatever happened. Also, if you have like references to internal system things, so like if you have a reference to a file but you don't provide the file, you've got a reference to like a embedding in a vector store but you don't provide the vector store, all of these things, caches especially, all of these things make your transcript not portable. In the old days, like for example, for images, you would like include the entire base 64 image in the transcript. That is something that is happening less and less. And yeah, like things like IDs, where you've got an ID into an internal database. These are all great things. As the people who make pies have their own biases and incentives at play, but I would argue that their incentives are much more community aligned, and they're more aligned with you and your incentives than the companies are. If you've got all these encrypted contexts, you just can't port that over. Most people do not switch their operating system or phone provider every week either. But even if you do not utilize that freedom, it matters because it changes the relationship you have with the provider and the provider has with you. The option to leave also creates discipline. If a provider knows that a user can continue elsewhere, it has to compete on model quality, price, reliability, and trust. So again, it's like this is aligned to you, not aligned to the model labs. The model labs would love to make this property not true. And so they propose some lists of things that the model inference API should promise. And also there's a little addendum here about how distillation is. Most of this is all designed to prevent distillation and to prevent portability. And at some point you just have to say, look, K3 is so good. DeepSeek V4 is so good. They're going to pass the quality of the labs. And then what are you encrypting for once that happens? The moral asymmetry is hard to miss. The labs ask society to accept that machines may learn from the enormous body of work humans placed on the internet, often without advance, individual permission, while insisting that other machines must not learn from outputs that the labs generate. It is kind of a little bit ridiculous. And I've seen some arguments against that, but it emotionally and intellectually, I think this is true. I think maybe the strongest counter argument is that it's a transformative act to create a model. The model then has like proprietary reasoning circuits that can be reproduced. But if you're going to do that, I think it could be also equally morally strong to say that training on the entirety of human knowledge deserves some sort of payback. I don't think that's true. So I also don't think this is true. I think that you should be able to distill. But that's just me. The formatter already knew about comments. Sanitizer keeps them now. Okay, so let's go back to our local version. We're going to go to the design. Hey, it's a lot nicer to work with. Styles are a little better now. Let's do the stronger model thing and agent history. These other ones, like maybe that gets solved by the stronger model and the agent history. I think there's a strong possibility. And this overly modal design versus text mode, we can just like come back to that later, because I'm actually starting to feel like it's paying off. Like with design, now you can have the CSS column here, and you can, as you edit the CSS, like for example, max width, let's say 2 EM. See? Like you see it live. That's cool. You see the output, and that's CSS. Whereas with this, it's nice to be able to see like you edit this and you see that live. And it's nice that like I actually am starting to kind of warm up to this idea, because it is a different thing to be thinking about the design versus thinking about the text. So, okay, let's leave that for now. But the two things that I do believe are we could use a stronger model, and that means I'm going to have to change the provider. And then let's make an agent history. Okay, so I'll say two things. Great. Oh, first let's like, please commit and push. See? Okay, it's doing a good job. It's saying, user said commit and push. Singular commit is fine for a working session like this, though splitting it would be cleaner. This is what I'm talking about. Like, whereas in the past, you would probably have to put that in a skill or in a MD file, like an agents.md file. This is saying like, I'm already got this in my history. I'm going to look at that history. I'm going to notice it, and I'm going to match it. Now, the big question. Yes, it still has the old version. When I republish, now I open it, has the new version. That's exactly what I wanted. So we're confirming that like the last set of features were actually correctly applied. I'm gonna go back into Ubuntu, and we're gonna do Pi again. And this time I'm gonna switch to DeepSeek V4 0731. Hey, that worked. Actually, I'm pretty happy with the work that Kimi K3 did there. Like, that was a pretty good session so far. Like, there were a few corrections I needed to make, but we were dealing with like complex stuff where CSS, live editing, we wanted to like work on a CSS thing, like this editor over here, which didn't even exist at the beginning of the session. I noticed that things were too compressed and too difficult to understand, so I asked it to prettify it, and it did. It also seems to be doing it live, so that, you know, if we do this, we're seeing this live change. I was able to make some changes, like I got rid of dark mode on this particular thing. So I just confirmed that like changing light mode for this document did not change light mode for this document. Like this document kept its mode. So that's cool. And same with this one, this older published document. That saved its work. So that's cool. What we were talking about before. We need a stronger model and we want agent history. So let's start with the history. Let's say, please understand the agentic sidebar and everything that goes into it. I want you to build up a strong, confident understanding such that you could adeptly handle any request that comes in to modify or change the way it works, because you have a total understanding of the current way it works and how it fits in with all the other parts of the system. Start with that. So I talked about this before, where especially with these smaller models, it can be useful to just have it, like tell it to explore and build like a specific sub area of where you want it to be highly confident about. And that will help it, like it will read the full files. It will read this, like the dependent files. It will build up a good understanding. And then once you do that, then you can guide it to where you want to go. This is not something you have to do for every model, especially the biggest models. You can kind of just like give it the task and let it figure it out. But I find that as you go smaller and smaller with the models, this step can help more and more. Look at the price we're looking at here. 0.008. We're less than a cent. We'll see what the quality difference is here. Like K3 is clearly going to be a bigger model. It's a bigger model, a better model, but DeepSeek V4 Flash 0731, this model is super cheap. Okay, so it's cool. We're still seeing the thought, even though this is a different model. This is that DeepSeek V4 Flash. We're still seeing the thoughts. Let me take a look at a few more things. The store, the render, the Kate set deployment, maybe the README. Check out preview.ts works. Check editor setup.ts, keymap.ts to understand the sidebar triggers. Since the user is asking me to build a strong, confident, complete understanding, let me summarize it. This is kind of like it distilling. It's distilling itself down so that this is the thing it's going to reference for the most part in future. This is part of it. It's like having it do the exploration is one thing, but then naturally, I don't know if it's naturally or if it's through the training data, it summarizes everything that it found and learned. And then this summary ends up being a critical message. So it's confident. It's got enough. It's got the UI, the wire, the server route, the agent, the theme, the config info, the test. Okay, here's the thing. The agent conversations right now are completely ephemeral. If I click, that old chat is gone forever. This has worked fine up until now, but does not suffice anymore. We must build a solution such that we can go back and resume an older conversation from exactly where we were. I want you to store the conversations in that same bucket in a subdir next to the document, so that for each document there is a separate list of agent conversations, which then we need to add UI for the user to select and resume. I don't want you to store any state besides cache, potentially, on the server or in any database. The source of truth should be what's stored in those buckets. I want you to continue to use Pi as the coding agent. Be sure that the UI that you build to support this is extremely high quality, not bolted. I'm going to start with just like conversation history. But I think what I really mean is that I want model choice. Like I want there to be a drop down and model configuration. And then it's going to make it a little bit harder because even when you like load up a previous session, like I want it to load up that model, but then I want you to be able to select and choose a stronger model and then resume the conversation from there. Let's do these things. Luna, K3, and DeepSeek V4 Flash. I haven't tried Inkling-Small because it is a weaker model and it's about the same price as this. We can try it later, but okay. So what's this doing here? Wow, a lot of thinking. It's trying to say, hey, do we need to store the raw Pi session JSON? I mean, for me, that's just obvious. Yes, like we should. But this con is true. The session JSON is Pi's internal format. It may be large. It may contain API responses and thinking. It's not a great format for listing conversations. The server would have to parse it to get titles, but actually Pi's session format might. I do think I would do this. I would store the raw Pi session JSON. Let's see if it comes to that same conclusion, but I don't want to create one thing and then like a source of truth and then a derived version. I want like the server to just load up the source of truth and maybe on the fly dynamically provide the revised version. It's going to store both, it seems. I don't really see the need for this transcript.json. It's figuring it out. I'll just keep letting it go. Ooh, we're at 3 cents now. 3 cents for this session. I don't know if I can afford that. This was significant. $11.08 and 80 cents is not trivial. For that amount, all I did was the CSS change. And while that was a big feature that was added, I mean, like, and I did have to steer it a few times, that's not insignificant. If I was doing all my work on that every day, all day, every day, that would add up. Whereas with this, I think I have a lot more confidence that this would stay as a low-cost option. Once we have that merged, I was talking about how I want a model switcher. Now that we have agent history and we can switch between past and future sessions and past sessions or create a new one, I would like us to add a new feature, model selector. Right now, we only have Grok as a model provider, but that is not sufficient for the work that we're going to do going forward. I don't want to remove Grok and GPT OSS 120B as an option. A, I don't want it to be the default anymore. And B, I want to be able to select from a set of pre-approved provider model pairs that can be used for different tasks. Here are the model provider pairs that I would like to be able to select from. I would like control over the configuration in the code. The user will just see the model name. The display should show on the right sidebar and be available at any time for design mode, text mode, and even once you've loaded a past conversation. When you load a previous conversation, it should definitely automatically select the model that was last used in that conversation. But if you switch models, any messages going forward should use that new model. And there's been a new release in MCP. I was really excited about it mid last year. I originally had done a lot of one-shot work, and it was all about like carefully preparing the best prompt, and whether that prompt involved like immaculate examples of how to do something, or great examples of what not to do, or contrastive examples of what to do and what not to do together, and like trying a bunch of different combinations of those things, but ultimately getting to a thing where there was a one shot from, I've got all of my data in here, I've got all of my instructions, and I'm expecting the right answer output right away. You can only put so much data in that context. You can decide ahead of time what data points are going to be relevant to that question. So if it's like code quality, you can start by just putting the code in there and saying, what's the code quality here? Or like estimate the let's say like you're trying to say like estimate the chance that a piece of code will take down production. You can start with just the code snippet and say, hey, we're going to put all of that code into the context, and that particular diff, let's build an estimation on whether this will take down production. But that diff doesn't have the rest of the system in it. So maybe you can say that every time that code references another piece of code, if it imports from that code, do one level deep of pulling that code into the context. And that way you're going to get a lot better performance, because it not only does the LLM have the code that it's modifying, but it has the changes. It has the changes plus the code that it's modifying. Well, you might start to think that, wait a minute, some of that code that you're bringing in references other code. Like there's a third, like it imports something and then the bulk of the code is somewhere else. So you could say, okay, do that 2 levels deep. Any code that my diff references, bring in that code, and any code that code references, bring in that code. And so you can say, okay, well, we're 2 levels deep, but that second level might actually import something that's the real source of the work. Or maybe we want to bring in the past history of this person, like the person who wrote the code in their past 10 commits. And then you might say, well, wait, why did we just pick 10 commits? What if the 11th commit was the important one and they had a failure in their 11th commit? That's not too long ago. So you can see where there's always limits to this. Like you have to choose what information you pack into that context window. And so my like breakthrough with MCP was realizing that with MCP, you get a row level decision. You can have the agent go and decide on a row by row basis sort of what things are interesting or needed for this thing. So if it's like the example I was giving before, it can intelligently decide, hey, this references this other code thing, let's bring that in. But this doesn't seem to like matter very much, so we're not going to go another level. Or like it looks like this user, like you can have the agent take a huge look at the user's entire previous commit history and then say yes or no that's not relevant to this search. So you can have an agent that really looks at and decides on a datum by datum basis per row what will lead to the best outcomes. And so for me, that was like a brilliant breakthrough. It allows this row level decision making and row level context decisions. But I found MCP towards the end of last year to be difficult to work with and bloated because of the problems that we're all aware of now, where MCP, you would put in your entire description would go wholesale into the model. Like all the descriptions of all the tools would just be plopped into the model. And if you had more than 3 or 4 MCPs, if those MCPs had a bunch of tools in them, and then like one MCP might have like 50 tools, and then another MCP might have like 1 tool, and then that 1 tool gets used a ton, but then of the 50 tools, there's like a long tail issue. And how do you manage like leaving room for your conversation and leaving room for your context? And they ran into all these issues. And so skills kind of came around. And also MCP was this stateful process where you had to like load up and keep a live connection going with another service. And if you dropped that connection or lost some of the configuration of that connection, you had to start a new connection to the MCP server. And so it had all this statefulness where you had to maintain a lot of this state. And that led to complex integrations and complex implementations and a lot of problems in different implementations. But so MCP had these problems. And then sort of along came skills and this thing called agent skills. And agent skills had this concept where like it had progressive disclosure. So in each skill, you would give like a short description and then the long full skill description. And then the long skill could like reference other files that were bundled up along with the skill and code. That's, I think, something that people don't even still see about skills is that you can describe and then bundle a library and then have the MCP, like the agent that reads the MCP, write code in Python to execute your library code. So there's like a bunch of flexibility in skills that's really cool. And skills have this like progressive disclosure. So it only shows the short snippet to the LLM, to the agent, and the agent only when it thinks it needs to can pull in the full skill. And then only when it really needs it does it need to go and read like some of the reference files or something like that. So to me, I was thinking to myself, MCP is overly rigid. There's problems with the protocol. It's got all these issues where like it can't scale up to many very different MCPs. And we've got this skill thing that comes along, which is like solving all these issues. It seems like a more flexible protocol. It seems easier for people to pick up and use it. And like maybe MCP was just overkill because agent skills gives us everything we kind of need. If you want to load 20,000 skills, you still have to figure out how you like when you pull those into context. So once skills sort of proliferated, now we're starting to see the issue where there's like even just those small snippets. You put 200 of those in your context window, and it's not going to be too crazy to have 100 or 200 skills these days, where each skill might be like one really specific use case, or like in one area of the code base this skill is important, but in most of the areas of the code base it's not. So you can imagine like it's really easy to accumulate skills, and now we still have the same problem we had with MCP. But in the meantime, the MCP people, they ran head first into this problem. The problem was so apparent from the beginning. It's like why a lot of people, like why I was excited about skills. And the way that the MCP people solved this problem was to create a tool search tool. So you're basically adding you're only ever exposing one tool to the agent. It's this tool search tool. And once you do this, it kind of solves a lot of the, like you have to make it a good tool search tool, and it has to work well and accurately. But with a good tool search tool, and that being the only thing that's exposed, and then the ability to load the tool when you want, that allows for not only much more granular control over stuff, like you can just expose subsets, just subtools of an MCP rather than loading up the whole MCP. It also just means that you can load up thousands and thousands of MCPs if you want, as long as the tool search tool is good enough. So they basically just like ran headfirst into this problem, solved it the way you just need to solve this thing. And then meanwhile, agent skills kind of proliferated and became this new problem where now you've got 1,000 skill descriptions. How do you know when to load those in? With the MCP, you get more granular control. With the skills, I was talking about how like with skills, you get this ability to just like bundle a library and have the agent write code and execute code on the fly. But you can't really control that. Like you have all these like wide open solution space. Some skills might use no libraries. Some skills might have a Python library. Some skills might provide their own execution runtime. Some skills might, so like skills are completely wild west in terms of how they might be implemented. And while I talked about being able to use like this dynamic programming solution where skills dynamically output code that it then executes, meanwhile, in MCP land, you can basically set all of your tools you can put your MCP into a harness that loads all skills into a programming environment and exposes all of the skills in that programming environment. So you can say it's only going to be a Python script or it's only going to be a JavaScript. And you access the skills through this like dot, like when you type dot, that indexes into the entire skill tree, and then you can index into the skill name, and you can pull out the tool that you care about, and that can all be done in a structured way. So it does seem to me that like I've gone back and forth. I started with being really bullish on MCP and being excited about it. And then I was kind of like tossing it in the trash for all these skills. And now I'm kind of coming back and seeing that like the MCP people had to solve the hard problems first. They had to solve them the hard way, and they got to the solution set. And now once they're there, there's a bunch of like nice things that you can get out of this. You can dynamically, like I said, you can enable a code mode in the MCP layer where it's all being presented to the LLM and to the agent as a specific coding environment. Whereas with skills, it's kind of up to each skill how it's going to do that. So that's my like quick overview of like why I think MCP is still important and interesting. Also, there's like with MCP, we haven't even talked about auth in the enterprise. Whereas like with skills, you can totally build an authful thing, like a skill that calls out to the GitHub API. You can have it so that GitHub API CLI or something requires you to have a specific authentication. And then if it doesn't, then it could kick it back to the agent, and the agent can ask you to auth, and then the auth can be sent into the skill. And you can totally build a enterprise auth stack around skills. But again, it's not like in the spec. It's just something that you decided to do and you decided to conform to. And if you pull in a third-party skill that doesn't conform to that enterprise auth stack, then you just have a problem. So I think it's interesting how MCP gives you this like narrow layer that you can put auth, you can put your LDAP, you can put your enterprise, whatever it is that you want. Like this is one area, one place that you put it in, and then all the MCPs sort of like get that and either deny you from using it or allow you to use it, or however that ends up working. If it wants to pop open a capability question or whatever it ends up being. So anyway, all of that is to say why I still think that MCP is relevant today. I originally for a while thought it was kind of toss it in the trash, but now I'm kind of thinking it's here to stay. This is a huge update that changes the entire spec, and it was just published a few days ago. And the main thing is that it becomes a stateless protocol. So whereas before I was talking about how you have to open a connection, and then the connection sort of like you have to maintain state where you're passing that state back and forth. If the connection drops, you have to reconnect, and there's all these difficulties with implementing this. This new protocol allows that to be a stateless operation. It means that you can do header-based routing. This is basically turning it into a nice API that acts like every other HTTP API out there. MCP is transitioning from a bidirectional stateful protocol into a request-response stateless model. This makes it a lot easier for everything on the internet. There is, of course, more to what we're introducing with this version. Every request is self-describing, with an optional discovery call for clients that want capabilities up front. So any request can land on any instance behind a plain round-robin load balancer. It makes it so much easier to scale. Shared nothing architecture. It also means that method and tool names travel in the MCP method and MCP name HTTP headers. So gateways can route and authorize on headers directly. That's amazing. I didn't even read that actually at first. That's cool. So that you can just, it doesn't even have to look into the body of the request. It can just look at the method, look at the name in the header, and route to, like, maybe you've got some server that's handling all of the MCPs named XYZ, and you've got another set of servers that are handling all the MCPs with ABC. Makes that super easy, and a lot of hardware, like these hardware routers have hardware that can look at the methods or the HTTP headers without even looking in the body. Also, that has to do with encryption as well. Server to client requests for things like sampling and elicitation are being redesigned to use multi-round trip requests. List responses carry cache hints and a deterministic order, so clients can cache tool catalogs and keep upstream prompt caches stable across reconnects. That's amazing. Formally locking in on a proper extensions framework with tasks joining other extensions, such as MCP apps and enterprise managed authorization. And they've updated the TypeScript, Python, Go, and C# SDKs. So let's look at MRTR, because, okay, it's clear that we're not going to want like a handshake. If we're doing everything statelessly, we don't want some exchange to have to happen at the beginning of each request. That would be a bunch of back and forth that you don't want. So now each request travels on its own and carries the capabilities in meta. Okay, fine. But I am curious about this MRTR. So it's like basically an error type, a specialized error type, where you're saying, hey, error, I need like input required, and then a blob of what the input is. Authorization, this is, like I said, the big one. And tasks, I actually didn't know about. Okay, tasks move out of experimental. I didn't realize there was an experimental tasks protocol extension. It allows the server to respond to a call request with an asynchronous task handle instead of a final result. Yep. Allowing the client to retrieve the eventual result by polling. Yep. Task get, task update, task cancel. Yeah, task result is a blocking trap. If you start calling that and then it doesn't return and you want to like change something, you're stuck because you're blocking it. That's totally makes sense. Client-hosted tasks are no longer expressible. This is all to adapt to this new protocol. And it seems like they've figured it out. If you hit cancel, you should be able to route that cancellation into the MCP and cancel the whole task tree. So anyway, MCP now having a stateless spec is incredible. I'm very happy about this. It makes everything easier. It sounds like there's a lot of people involved, a lot of companies involved. I think MCP is here to stay. And I'm excited that like we're getting a better MCP as well. The open source community is backing OpenEnv for agentic RL. You can see a long list of people that are involved with this, and some of these people are like people that are working on all different aspects of the industry. So, like for example, Will Brown works at PrimeRL, and I don't know. There's a bunch of different people here that are like working on a bunch of different parts of this, and you can see the list of companies that are listed here. So to me, this is very exciting, just based on the participation, just based on who's all involved, because having an open source spec, it means nothing if nobody's bought into it. So the fact that like Hugging Face, PyTorch, Reflection, Unsloth, NVIDIA, Microsoft, Prime Intellect, Modal, Mercor, Fleet, Radix Arc, these people have all bought in is very exciting. And I was looking, there's like Microsoft supports this in their Azure Model Studio or something like that. Prime Intellect supports this in PrimeRL. Hugging Face supports it in TRL. So there's a lot of good support that's coming for this spec. It's exciting. In also VLLM, SkyRL. SkyRL it basically builds an open source variant of Tinker. Axolotl. So all these. So there's just a ton of buy-in, which is great. But you might be saying like, why? What's the point? The point is this, that there's a bunch of different trainers out there. We've got the Azure Model Studio. There's all these different trainers for basically taking a reward signal and turning it back into the training into the model weights. We've also got a bunch of different harnesses. We've got things like Pi. We've got Open Code. We've got Codex, we've got Claude Code, So we have all these different harnesses, and there's going to be more. And then we have there's like different environments. There's like a bunch of different environments, but the environments do not conform to any standard. There used to be like an OpenAI gym, but if you look at this, it's been deprecated. It's a public archive. It's been deprecated since, well, only April 7th, but it stopped support in 2021. But this has been dead for a really long time. But this was kind of like an early version of what you could consider like a common standard, where you had like gym.make and it would create an environment, and then you could reset the environment and get an initial observation and some information, and then you step in the environment with an action and you get like all these things. And when you look at this, you're going to notice this is kind of a standard machine learning concept at this point. We've got this. But if OpenAI Gym has been deprecated since 2021, and we've got all these new training modules, we've got different trainers, we've got all these different harnesses. This gym was never meant to work with like the open code harness or with Claude Code. Like, it just was never meant for that. And then this Python definition, it's like reset, step, make, reset, and step. That's fine, but that's just a Python spec. So what if I want to write some code in Rust? Or what if I want to write some code in something else? So you're starting to kind of see this, right? That we've got all these trainers that have standardized ways of loading language models. We've got harnesses, which have standardized ways of loading these various models. But we don't have a standardized thing for like this environment or how to plug it all together. And that's the thing that's kind of like it's one of the big things that's been holding back open source in general. Like, it's hard for when one company comes out and creates an incredible environment, it's hard for all the other open source companies to plug it into their inference stack and their training stack. They're not saying what your outputs of this need to be. They're not saying that like you need these specific reward signals, or you need these specific observations, or you need this particular shape of info, right? We need a protocol so that any language of any harness can plug in their trainer, their harness, and then plug into any of these environments that conform to the right protocol. And so this has become that interoperability layer on the surface. And it says, in practice, this means one interface, many environments will all expose the familiar gymnasium-style API, meaning reset, step, and state, which you've seen from this. Reset, step, and then I guess this is sample, state. Running on a client-server architecture. So a trainer that speaks OpenEnv can drive any compliant environment without bespoke code. And so there's interoperability across env libraries. Also, things like, so when we're talking about the agent world, agents are served over HTTP and WebSocket and packaged with Docker. MCP is a first-class citizen, right? So that like, if you have an MCP server, you don't have to write custom code to figure out how it fits into this environment, how it fits into that environment, how it fits into this trainer. MCP becomes this first-class citizen where all the trainers and all of the environments know how to load it in. It's got a standard description language already, so MCP just slots in. And then we're talking about like all these new things that they're going to do, more external rewards, and task sets versus data sets, which is an important thing, and more different harness integrations and end-to-end examples. We've seen a lot of this. We've actually seen a lot of end-to-end examples. But so this was the post that got me all excited about this project. I'm thinking, hey, there's a bunch of buy-in. It seems like it's attacking the right thing. It's a protocol. And I would like to use it. But so here's what happened for me, though, is that I went over to OpenEnv, like this interface library, and I got very confused. I was having a hard time figuring out what is the protocol? Because what this is teaching here, you'll see, is like, how do I import OpenEnv, the Python library, and execute Python code. It's saying here, you just saw it in action. env.reset, env.step, env.state, env.close. So it's like, it's showing it here, but then you go up to like what it just demonstrated and it's like show OpenEnv observation. And it's OpenSpielEnv. And it's this grpo utils thing. So I'm thinking like, what the heck? I don't understand what this is trying to demonstrate. It's like showing me a specific Python import thing and then telling me it's something else. And okay. So then we've got this like play random policy. It's got these actions. It's like different API. And then this is trying to teach me about grpo and reinforcement learning. I know what that is. Like I know how this is, but this is very strange. And it's teaching me like from PPO to grpo. So this is like the first example that you get when you go onto the site. And it's saying, okay, where it's going to do group optimization. You need like, it's going to do group relative rewards. Great. It's just trying to teach me RL. And it's trying to teach me PyTorch and TorchForge, which I think is TorchForge even deprecated? I think it's like deprecated now. Yeah, development in Forge is possible. So it's teaching, it's like the first example is coming from a deprecated thing using incorrect implementations that don't match the new thing. And there's this open spiel. Like it's very confusing. So then I thought, okay, that's weird. Let's look at more examples. And so I started looking for like different, more legible examples. OpenEnv simple. And this is cool because it's like, okay, I'm starting to see, I got a basic instruction. I'm importing this open code env. There's like a rollout result of some type. So there's like a library here. There's like a framework inside of this OpenEnv stuff where I can like, this is coming straight from the OpenEnv stuff. So I'm thinking that's pretty cool. But it's hard because like in OpenEnv here, they're talking about this basic gym environment, but then in here, I'm not seeing here, like, let's see step. There's no step. There's no reset. So that's not great. I'm excited about the concept, but like I was looking for the actual, where's the protocol? So I'm on board with the idea for there being a protocol. I'm on board with there being a library to even demonstrate the protocol. I'm down with like a lot of the parts about this. And it looks like there's all this stuff, right? Like, but wait, my question is, and this shows how to run an environment. It shows like the sync step, client.step, and how to call it, like call a tool call. So it shows you how to like use their library and like their library's abstractions on top of their library in order to drive this protocol. But my thing is just like, what is the protocol? What's the actual protocol? This OpenEnv protocol that they talk about. Like, what is this? And what is a protocol? It's saying so clearly that it's a protocol layer, not a reward framework. And so I was really having a hard time figuring out where does the protocol end and the library start? And where, like, for example, if I use PrimeRL, what part of that needs to be exposed for OpenEnv? And so I created this project over the past week called Mini OpenEnv. It's a vibe coded thing just like any other, but I had it figure out and I made it in C99, because I was worried that any other language that I chose, there was going to be some open source thing that it could like search for, find, and like include. And I wanted it to be difficult to write. Like I didn't want it to just be able to spit out code. It must conform with the OpenEnv spec in Python. And so by doing a C99, doing C, it made it so it had to be very intentional about what it supported. And you can even see like the reference implementation, Hugging Face OpenEnv, is 752 Python files and 164,342 lines. And the protocol is buried inside those lines. It's just and here's what it is. It's a JSON envelope with 4 keys. It's 7 WebSocket message types, and it's 16 routes. Many of these are not even necessarily needed. So what I did is I had my agent download the env spec, boot up a bunch of environments, and capture the traffic and figure out what is the actual underlying spec. What's the protocol? I created like a docs page, and this docs page is really nice because it gives you like a couple of different doors to go down. First of all, you can like figure out what is the protocol. What is the protocol? Which, let's just talk about that. This is the protocol. The openapi.json lists out the routes that are available. This is like a standard thing. There's a /list environments, which gets the list of all environments. We've got, there's this concept of this task API, but nothing ships it yet. This is like an RFC that's it's a proposal to the spec, but not actually there. There's a WebSocket request for MCP, which allows you to do, by the way, like as I had it create this documentation, it also has by itself, it created spec gaps and reference warts. And so if you look at like gaps and warts, it found 24 gaps in the spec. And a lot of these are like sequencing. What happens if this message comes before this message when it's not enforced? What happens when like, do you have to call reset before you do everything? Or is the first one reset automatically? Like there's a bunch of these gaps where there's just not a defined part of the spec. But then this wart is like, the reference does this odd thing and we reproduce it. And it found 28 warts. For example, the claim /reset starts an episode and step advances it because that is what the names mean and what every RL API does. And in our reference, each handler runs. So this is each reset, each step request. It runs self.envFactory and then closes it. So the instance that served the request is destroyed before the response is written. So if you step and you pass it amount to 3 times, then you would expect it to do 2, 4, 6, right? You'd want it to like, when you load you'd expect it to be incrementing each time. But each time it's just adding 2 to 0. The encounter environment returns total 2 3 times, and then the nested metadata reads steps 1 each time. So it's like stateless in a dumb way. So basically, it's not a stateful protocol if you use the HTTP endpoint. If you do /WS and you open a WebSocket, then you get the good behavior that you would expect, where changes of states result in the output that you would expect and the state changes that you would expect. Yeah, this is called the stateless surprise in this one. This is the API. You can get the state, even though it doesn't really make sense. You can get the metadata, even though it doesn't make sense. There's a health endpoint, which is just a good idea to have. There's a schema endpoint, which is great because you can have, it's like basically a self-describing API, similar to the OpenAPI.json. Schema means that it shows you a JSON schema for the action and the observations. And then posting to the MCP allows you to do the JSON RPC for the MCP stuff. But here's the main thing. Like this turns out to be like, this seems like this was an idea, but nobody's using it. And this seems to be like the thing that everything uses, which is the WebSockets. WebSocket, when you open that and you send these JSON, this is the real protocol right here. Sending the reset, type reset to the WebSocket that you've opened here. Calling step, getting state, asking for state, closing it, and MCP. And then what you get back through the wire is observations from your steps, states from your state requests, errors from any errors that happen, and MCP responses. So that's the envelope. And then they say every observation is in this envelope. It's observation, which has a whole object that can be whatever. The reward is a build, like the reward from like the environment. Done, whether it's finished, and then metadata. So this is what this was talking about, is the stateless surprise. The route table is marked reset and step stateless. And that word is doing more work than it appears to. A counter stepped twice over HTTP. So this is me saying, this is what it's saying again. 2, then 2 again. Now, if you do the same over the WebSocket, OpenEnv WebSocket probe, which is like this thing that this built in mini OpenEnv, and you say run 2 steps where the action is amount 2, you're going to see that it actually increment. So when the WebSocket stays open, it becomes stateful. And so then the agent created this whole list of oracles where it compares an agent that's driving like an OpenEnv Python env from Hugging Face that's driving it versus my C library that's driving it. And through all of these, we were able to match it byte by byte. So that's pretty cool. And so if you look at like the different line counts, there's just like way more stuff in the OpenEnv reference, whereas this is just tiny, it's minimal. And so, okay, implementation of the OpenEnv protocol in C. There's a reference implementation in the Python server that's like 109 lines. This is a lot more, but we're completely building everything inside this one C file. And so you can see like we're just importing buffers, HTTP, JSON, net. Okay, there's stuff in the wire, I guess. But yeah, the protocol is much simpler. It's just reset. There's some, so this is a little bit not pedagogical because it's hard to read through it all. It's C, but this is all you would need to do to implement using this C library. Go. Annotated episode. This is what I wanted to show. Because yeah, I'm glad that it like created this. We've got a conformant thing like that. This one is a minimal one where it's just doing the bare minimum. This is more conformant where it's doing more things. And we're pulling in from OpenEnv, so it's got some more like in this OpenEnv.h. There's a lot more convenience functionality. So you pass like these are the fields that are available on the counter environment. These are the observable fields. So like there's an amount, there's a total. Like the running total is like an observation. The amount is how much that you're going to add to it. And then every time you add an amount to it, you get a new observation with these new totals. There's an actual counter that is the struct in C that's going to store this stuff. We've got the actual function that does the work. This is the actual meat of the environment itself. We've got a reset function that like knows how to take this counter struct and reset the total and the steps to 0 and reset it, and then knows how to save that out. We've got a counter step where we're going to parse out the amount. We're going to add that to the total. We're going to add 1 to the steps. We're going to set all this stuff on the fields, and we're going to say we're done, and then recalculate the reward. This is another one for the encounter state. And then this is like a little description where we're creating the environment with a name, with a description, with a task environment name, with the action fields we talked about, with the observation fields we talked about. So this is like a convenience wrapper creator using, this is kind of like what the nice way of doing it, using the OpenEnv.h that this agent created. So this is like the crappy manual way with a lot of code. And then this is like a nice conformant, easy to use one. And then here's a client where it's a client of the server. So it's doing both ways. This is the implementation of the server, and this is the client of it. And this is like crappy. Like you would not use this. This is just a way of like debugging and showing like what a client might look like. In fact, I'll demonstrate it in a minute. And then we have examples. Well, I'm not going to do that right now. Okay, but going back to this annotated one. So this was one where like I had it, I told you I had it download an environment and like run some stuff through it and capture the output and use that to build our implementation. Okay. So this is the annotated back and forth where I captured a bunch of traffic, and this shows exactly what the protocol is. It makes it easier to understand, in my opinion. So it started out, there's an opening handshake. You get the WS WebSocket, and WebSocket does an upgrade. This is a standard HTTP request. That HTTP request upgrades the socket into a WebSocket. Now it's a WebSocket. From here on, every message travels in a frame, a short binary header, then the payload, which is the message itself. The header says what kind of payload follows, the opcode, how long it is, and whether it is masked. Frame 1 spends 6 bytes on the header and 26 on the payload, and the annotations read the header back a bit at a time. Masking is the one rule that differs by direction. A client XORs every payload byte with 4 fresh random bytes called the masking key carried in the header. A server sends its payload bare. RFC 6455 requires both, and that is why a captured client frame looks like noise, while a captured server frame is readable text. The message inside this frame is reset, start an episode, and send back the first observation. So when you first connect to it, once you connect to it, a WebSocket, it upgrades to the WebSocket, and then the first thing is, so this is sending the frame header. Byte 0 is 81, says it's text. Payload is 26 bytes, and then the following is the masking key to 4 mask bytes. Every payload byte on the wire is XORed with them. This program sent a reset message through the WebSocket. The payload as we wrote it. On the wire, every byte of it is XORed with the 4-byte key above, which is why a capture looks like noise. Anyway, okay, so then we get 2 bytes back, which is the frame header, saying it's going to be text again, and it's going to be 118 bytes. Then it sends those 118 bytes, which is an observation message. And the observation has metadata, total, and last note. That's the observation. The reward is null, and done is false. Okay. So this is the reset and the first observation. Then we're sending our header again. It's text and it's 35 bytes. And we're going to say step by the amount of 2. So in our data, we have this object, and the action is that. That's the action. So if you post to /step, that wraps the exact identical object. That asymmetry is the single thing a handwritten client gets wrong first. So what this is saying is that this would be like, if you post to /step, it's going to be wrapped in an object with an action key. Weird. It seems like they don't have it figured out between what's the WebSocket and what's the HTTP protocol. Anyway, okay, so we're sending a step message. This is saying like, I'm actually going to step the environment forward, and I want to like set the amount to 2 or increment the amount by 2. Then we're going to receive a frame that says it's text again. It's 126 bytes. Now this 126 bytes does have metadata. So remember, it's observation, which is the observation itself, which this is the observation, which has its own metadata. We wrote that metadata in there of steps is 1, total is 2, and last note. The reward is 2 for whatever reason. Reward is a float. On this transport, that means the environment produced a float over HTTP. It would mean nothing at all because HTTP corresponds every reward to 1. It's so like passive aggressive about that. But anyway, it still says it's not done. And now we do have metadata where there's 1 step. So we're going to send the frame header again. And basically this is the exact same thing. We're going to send the frame header and then the step, frame header and then the step. And we're going to get a response saying it's another 126, same 126 because it's the same data. Instead of having 1 step, we've got 2. Instead of our total being 2, we've got 4. And our reward is now 4. Done is true. And then their metadata includes steps 2. And that means that this environment has decided to end it after the 2. So 2, then 4. So we saw it increment. This is right. So that was the step. That was demonstrating the step part of the protocol. Now let's look at the state part of the protocol. When you're your client asks an environment state, which is just sending it this one message. There's no arguments with state. It's just state. It carries no data at all. It's a request for state. So then this is going to say, hey, I'm responding with text. I got 74 bytes. And this is saying, this is the state of it. It's got this data blob, and the data has an episode ID. That's just what it has decided, is to have an episode ID, have a step count, and a total. But this is all application specific. This is all environment specific. Our environment that we're interfacing with chose this as its state. And so we got that final state. And then this says close. Close ends the session and is the one message answered with silence. No observation comes back. The server breaks its loop and starts the closing handshake instead. Each side sends a small close frame and a goodbye, so the socket ends by agreement rather than by dropping. And then the probes, half of that goodbye was written into a frame header, not by any caller. So we say close. We've got this little dance, and then it's done. One question is still open. How does a client know what an action looks like? The probe never asked. Amount 2 came from its command line. So remember, we showed up here. Actually, I don't think I called it out, but this said this probe function, it connects to an OpenEnv, and then we said this episode steps 2. It's going to send this 2 times, basically, is what it's saying. It uses no protocol code of ours. So we're learning the protocol by inspecting this back and forth. So we closed it. Okay, typing channel, schema. So instead of doing that episodes, let's do a schema. So we're just going to connect to this server and ask for schema. So it sends the HTTP request to schema/schema. And then the response comes back with this big JSON blob. And 3 JSON schema objects: action, observation, and state. This is what we get back. So look at action. It's got a JSON schema. So that looks like there's going to be metadata. It's going to be an amount, and there's going to be a note. Metadata is itself an object, which should be any object. It's open. Additional properties are true. Amount is going to be an integer, just one integer. So it's going to increase or decrease, but it's an integer. And the note is a string. And then the title it's going to have a title called counter action, which will always be title counter action. So the field is title counter action. So that was the action. It's like, what are we passing when we do step? What are we passing is this action, step of amount 1. We didn't do any with a note, but we could have. And then the metadata, what did we set when we stepped? Nothing. And then observation, it looks like it's going to have a done property, which is a Boolean, a reward property, which is a Boolean, an integer, a number, or null. We've got metadata, which is just an object. We've got total, which is an integer starting at 0. We've got last note, which is probably, I'm expecting, whatever the last thing you sent in under note, which we never did. And so this is telling you the action that you're going to send. This observation is the observations that come back. And if you look here, these are the observations we saw, where it was metadata, total, last note. And if we look here, metadata, total, last note, and there was done and reward. Yeah, done and reward too. I just didn't mention that. So then finally there's state. Description is base class for environment state. Represents internal environment state separate from observations. So this is when we asked for state here, when we sent that state message, we got back this episode ID, step count, and total. And I bet that's what we're going to see when we, that's what we're going to see when we look here. Episode ID, yep, which can either be a string or null. Step count, which is an integer. And then title state, let's see, total. Episode ID, step count, total. Episode ID, step count. Get state, which we do down here, or which we showed up here, or where did we show it? Get state would have shown you exactly two keys, episode ID and step count, because it truncates to the base state model. This is a wart that it found. So I was just noticing that. So this, yeah, it seems like there's a base JSON schema, which includes total, and this truncates that, I guess. So I found this very helpful to help me understand what exactly is the OpenEnv spec. The OpenEnv spec is basically this WebSocket that has these specific JSON schema and these specific JSON keys, which you can discover and understand by asking for the schema, and that's it. That's actually it. So there's the spec, and you can like go in and read about the specifics of it and exactly what happens when a validation fails, what happens like in the stateless version of it, how a non-Python client learns the shape of this stuff, and then the MCP stuff, which is interesting. I don't need to go into the MCP stuff now, but that's all captured as well and reproduced into this library. And so this is telling you what are the things that a server must do. The server must respond with health, open API. It must have a reset. It must have this MCP. It must have a WebSocket. The WebSocket must upgrade. The WebSocket must speak this protocol, basically. And then clients have a certain set of obligations too. They have to like look up this stuff. They have to poll the health periodically. They need to open up exactly one WebSocket. They need to, send the right things there. They need to send the right types of frames. They need to encode it properly, do the XOR stuff. Apparently there needs to be, well, this is just like maybe an implementation thing, but under 16 megabytes per frame. If a server pings, it needs to send a pong. So like these are things that it has discovered that it needs to do. So I created this conformance tests, and it does all that. Let's take a quick look. It already pushed it. Model selector, a dropdown in the agent panel, always visible, list view, thread view, and text design targets. How it works. Code controlled registry in server source agent models. That's exactly what I wanted. The 4 pairs you specified with pretty labels. The client sees only the label. The server resolves the ID back to the provider model API key thinking and passes them to Pi explicitly through model. Okay. Verified working. I ran all 4 pairs against the real providers. Great. Per conversation memory. The model is recorded as per turn in the transcript. Resuming conversation auto selects its last used model. Switching models affects only new turns. Every load prefills in the conversation's model. Old conversations without a recorded model fall back to the default. Perfect. GPT OSS 120B kept as an option, no longer the default. We deployed a new secret. Perfect. It's got OpenAI together, fireworks, and keeps Grok. Config map is updated with the obsolete provider and model, which was like a singleton. The Docker file pins Pi to 83. And Claude.md was updated. That sounds great. I'll try it locally first. This is my local. So hey, it looks like it's got like, why did it load? I guess I told it the new default should be that. It's okay, it didn't save those things before. I'm not too worried that it didn't load the right model first, because I told it that I want the DeepSeek V4 Flash to be the new default, and it wasn't recording these things in the previous ones. So it's already better than before. But I'm going to undo that. Let's try it. GPT-5.4 Luna. Same 6 sections, but now each one has its own links sublist. Okay, so that's cool. Let's see. Everything looks great, but unfortunately, the OpenAI model didn't work properly. Is there possibly a misconfiguration? I did say 5.4 Luna. That was my bad. You're right on both counts. The ID is wrong, and my earlier verification was too shallow. Very nice. Okay. So while that's going, it's going to update the command. It shouldn't be take too much. This is cool. This was a very cool implementation. Fixed and pushed, the misconfiguration. Had GPT-5 Luna, which doesn't exist. When I click around to different conversations, chats, it isn't automatically switching my model selector like I would expect it to. Maybe I just need to reload, force reload. I think it's because for the old chats that don't have model information saved, it's not treating that as GPT OSS 120B. It's just not setting the model. So when I switch to the new one with the new model, it changes. When I go to the old ones, it doesn't change back. We need to default all old chats to GPT OSS 120B. I think that's going to be the solution there. I'm going to pick 5.6 Luna. Give me some suggestions on what other topics I could include. Suggest them as big diffs. Hey, it did. Let's see what this looks like. Kind of cool. But no, I don't want to keep it. I'll decline and save. But okay, now if we go back to here, Kimi K3, if we go to here, GPT 5.6 Luna. If we go back here, GPT OSS. That's what we wanted. So we're getting it. No, it's kind of nice how it highlights the last thing you did too. Oh, we got deletes. What happens if I like, oh, undo? That's cool. There's an undo. I was thinking there should be confirmation, but I prefer undo. This is done compiling. It's done CI, push to CI. So I think all I have to do now is run the rollout. Now we're going to go back to NeuralColumn production. The August 8th one was the one I was looking at before. And look, the conversations that I persisted here locally, like they were all, it was speaking to this bucket up here and persisting it. So we got it. This is great. It's storing in B2. So check it out. This is my NeuralColumn bucket. I've got posts. These are the various different posts. You can see like some of them have had a bunch of different revisions. You can see like this one had 6 different revisions. This one had 15. Okay, so this is our post. We can see we can download it. And if you look at the page source, we're embedding all of the styles in there. And that's how, like, when we're editing the CSS and we save it, it goes in there. So that's cool. When I was showing this P, these are published. So these were all the different published versions. These are the source ones. And so this is I'm a user U2T3. We've got this bucket for here for 802. If we look at the body, this is like the original Kiln, like this right here. This is the body of it. This is the chat. We've got chats now. And we've got the Pi session and the transcript. And the transcript is nicely being versioned. The Pi session, surprised it isn't being versioned. Seems like it's probably being swapped each time, actually. But let's see. Yeah, no, that's being versioned as well. And so each one, this is a Pi session you could load up in your local Pi, probably. That's cool. So we did styles. We improved that by a lot. Diffs, not applying, we seem to not have that problem. This seems to be better than what I thought. We could use a stronger model. We actually are doing better on this. I saw earlier that the extension, there was an extension. And so we need to like investigate that and make sure it's good. But I'm changing my mind on some of this. On this one, as I went in, I had this idea, but as we developed it out, the design mode separation seems kind of good. Needs more help and guidance. We didn't do this. We'll do these later probably. Text preview style. This doesn't seem to be a thing. Visual design could still use some work. So the only 2 things we did were we improved styles and then we improved the model and we gave it a stronger model and gave it a model selector. And then we gave it history. So you can go back and see previous versions. So this is all that we did. Oh, I wanted to show, this was the last thing I wanted to do. So I think that you have enough information to know about, so we're done with NeuralColumn for today. This was fun. This was cool. I think we found the limitations of DeepSeek V4 Flash, the new version. I think what we found out is that past some longer context window, once we got to like 30% through, it started losing its ability, and it kept stopping before running tool calls. It would say, I'm about to do this tool call, and then just never did. So that's something that we should probably just keep in mind as we get longer and longer contexts, that the DeepSeek V4 Flash seems to want to sit in a smaller portion of the context, which is something that has happened with previous smaller models. Seems like the bigger models have less of a hard time with that. So we had to switch to Kimi K3, which is a bigger model. But we also paid $10. In addition to the 11 before, we spent about $20 on this session today. And we really only accomplished 2 things. But imagine if we had used Claude Fable or Opus 5 or something like that. We're saving a lot by using these already. And if you were paying an actual developer, it would be even a lot more than that. I charge more than that for my time, at least. I do want to share like an example of it. So let's do Maze. I'm going to host it on localhost, and I'm actually going to say 8021. Hopefully that works. And then I've got this ready to go. OpenEnv connect 8021, let's say. And I want to do VV, so this is like giving a very verbose version of it. So if you look over here, session opened. This connected. You get to see it, every single thing. So it connected to the WebSocket. It called reset. It sent a reset message, and it got back an observation. The observation includes this. So this is where we start to get into like my own mini standard. So on all these arcade things, it supports a field called input text. And the input text is like from the environment to you. So it's prompting you kind of. And it also includes an X, a Y where you are, the goal X, the goal Y. So it would be displayed. It's like you know where you want to go. And we haven't gotten any rewards yet, and we're not done. And there's no metadata. So it's saying, okay, 15. This is what the text from the environment was. The environment sent back text that said a 15 by 15 maze. This means a wall. That means a floor. A means you. G means the goal. And it says you are at column 1, row 1. Row 0 is the top. We've got left, right, up, down, 0 to 9. Enter, reset, trace. And these are all the things that I can trigger on my keyboard that send events to the environment, and the environment will send back. So it will call step every time I call this, right? I'm going to do right. I'm going to try and solve this maze. You can see the A is floating around. Wait a minute. I went the wrong way. Got to go up. But you see, every time I do this, I am sending a step move and I'm getting back an observation. This is a perfect example of using an environment and how we're able to interface with it and write a little client library where I'm the person running it, not a machine. But you can imagine hooking up an agentic LLM to this, and I'm trying to get to the goal. So it says reach the goal in 95 steps, return 0.06. If I would have done it in fewer steps, it would have done more. You can see this is just an example. You can see how it works. And yeah, so let's actually just do another one quick. Instead of maze, let's do snake. Okay, I go left. Space goes straight. Straight, right. 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 Oh no. It's actually harder to steer than you think it might be. Even though you have all the, like, it's not real snake. I have all the time in the world. The harder part is that like I have to think from the snake's perspective and go left or go straight or go right. And it's like hard because I've got my perspective. So it's kind of its own different challenge. I'm getting better. But this is exactly the type of thing that like an LLM could get better at. And it might be interesting to put in your environment some time limit where if the next thing comes in too much later, it counts as a fail or something like that. John Carmack thinks this is the wrong way of approaching it. He thinks that by having the client step the environment and say, okay, now I'm ready for the next step of the environment. He's like, that's not the way the real world works. The real world is an environment that calls, like, you, when you call the next step, if you've taken too long, you might have missed a bunch of opportunity to act. And so by having the environment call the step function of agents, he says that it's going to make us create agents that have more time accuracy. If you go off and you think for 5 minutes and come back, that's not acceptable in the real world. And so there's some benefit from responding quickly and not missing anything. And so that's an interesting perspective. And I think like we will see. I think John Carmack could really be right about that. But it's not the way this is implemented. This is implemented in the classic gym way where the environment is stepped by the client. As you can see, it waited until I hit enter. Every time I hit enter, it would step forward in the environment and push one more time step forward. And that's the way this works. You could keep a counter or keep a time, like log a timestamp whenever this environment gets in the next message. And if it took a certain amount of time, you could actually skip 2 time steps ahead or something like that. Totally doable, but it's something you'd have to build into your environments right now. Whereas what John Carmack was saying is that he thinks it should be inverted, and by default, that's the way it should work. So we'll see how that goes in practice in the future. But if you want to check it out, you can check out this mini OpenEnv project. This is a project that I created using one agent over the course of 4 or 5 days, just having it like continue to iterate. It's Apache 2. You can use it as like your environment library. Like you can implement, you see that with these Arcade, I've implemented a bunch of different clients. You can also use the OpenEnv client that this has created. You can use it as a client for yourself. This doesn't have to just connect to my environments that I've created. Like you could connect to an environment that's a open source one. Got a bunch of them. So you've got a code environment, you've got a math environment, you've got like these benchmarks, you've got humanities last exam. These are all OpenEnv environments now. So you could just run prime eval run HLE. Well, I don't know if that would spawn a OpenEnv or if you have to give a special OpenEnv arg, but you could spin up any of these environments here as OpenEnvs, and then you could use my client library, my CLI thing that I was using to drive this little snake game to connect to these and interface back and forth with these. So this is like the dream. And look at community. We've got people like ARC-AGI, we've got Prime Intellect themselves, we've got like all these open source people who come from the community. Will himself, for example. We've got all these people who are creating Chakra Labs. I don't even know who they are, but they've got a dojo environment. We've got Proximal Frontier Suite. We've got Frontier Suite environments. We've got Calamaze with an alphabet sort. That's interesting. Alphabet sort. This task requires the model to maintain and update an alphabetically sorted list of names across multiple conversation turns, with new names being tagged appropriately. Yeah, so just like cool little, so if you had, you can imagine like you grab a couple of these and you train a couple of these, and then you have maybe you have a bunch of environments that represent your task, your distribution that you care about, your particular type of coding, or maybe you've extracted a bunch of like trajectories from your live running service. Like if I could take these NeuralColumn, hit all this history and find places where like there was a mistake that was made that was corrected, we could take that and convert it into these environments and then train on that suite. So I think there's just tons of stuff, tons of exciting stuff to do with this, but this spec needs specking. This is not good documentation. This is not great documentation. This is great like usage documentation, but not great protocol documentation. The protocol is really hard to track down. And so that's why I'm glad that like my agent did this. It created from scratch implementation in a brand new language. That's why I chose C99. It's not a good idea in general. But I had Fable, I had Opus, and I had open source things all working on it. And in the end of the day, it is a good library now. So if you go to the README, you can say like, hey, I went through the parts that help us understand OpenEnv, but you could also just like use it as a reference. You can pass this protocol to an implementation where you implemented in another language. You can use this probe stuff to connect to an OpenEnv server and annotate and check. You can use this as a OpenEnv server. In fact, there's like a little Docker container that wraps it into, like, check this out. If you run make Docker, it creates this like tiny Alpine based, Scratch based, or it uses Alpine to build and then just uses Scratch and copies the binary in there. And it ends up with a 211 kilobyte container with just the binary in there. So there's some cool stuff that this library enables. It's not something that you couldn't do with Rust or that you couldn't do with another thing. But the fact that it's just like C99 makes it just kind of like easy to do these like super slim stuff. So you've got the server, the client, the protocol, the wire. Like, it's kind of fun. I'm probably not going to keep working on this. I will potentially keep it up to date. So as OpenEnv specs out and becomes more realistically like a real protocol, like I'll track it and make sure that this kind of follows that. But who knows if I'll create a bunch of environments using this C. But if you want to, you totally can. This is a way of creating a very efficient environment for OpenEnv. And I think we did a lot. What a trip. Thank you so much for staying with me for that time. Hopefully it's useful to somebody or something. Anyway, I'm Eric, signing out.